Sorry for the deadline. I'm going to scroll. I'm overly that we are starting. I hope this is going to work better than the last few times, and I also hope that I'm not going to get kicked off as I have on multiple occasions in the last few times. Uh, Today's going to be a big one. This is a rare and special occasion. This is such a special occasion that I actually have a physical checklist in front of me to remind me of all the things we're going to talk about. We're going to talk a little bit about the cryosphere part two. And that's actually that's something we may be talking about every few days and weeks. The cryosphere is it's the polarized caps and glaciers. That's the simplest way to put it. It's cryo frozen ice. We're going to do a little bit of discussions later today. Just the basics on the psychology of climate change, which Tim will host. And I am going to discuss today one of the more interesting topics, one of the most important topics to me in climate science, and that is what the process. It's not most of the time so it is completely canceled. Again, let's see if that works. All right, the alter count is up. We want to go into the big question of what is climate science. We're going to go into I'm going to talk about several aspects of climate science. It's of course most important being what is climate science, the physics, the biology, the chemistry, the geology involved, and the different branches of climate science, specifically modern versus paleoclimate. While occasionally stopping for a bite of this long infection. Yes, I know. I'm cheating. I'm chewing. Well, nobody's here yet except for the overcast. Chewing. Hello, Ken. The usual issues with today, which always happen with this really lousy software.
Were you today?
When we use the app, if you select AM or PM.
Oh, excuse me, Sal.
PM.
Excuse me, Sal. You're a bit muffled.
Go ahead and change that to AM. We're going to get the word out. Thank you. Yes. I have no idea why.
There's a little bit of an echo.
Well, probably we're going to have to. What might I may have to switch earbuds. So I'm going to take off here. Yeah, that I understand because when I linked to the alter count has a very small sound bar connected. So how do I sound now?
And I can't
hear you.
It's problematic. I hate this. This is always so difficult. Let me see what my phone is telling me. Bluetooth. Disconnect T9. Don't know why it was on T9. Forget T9. Forget device. I hate this. How am I doing now? because I can't hear you. So I need you to come back up to tell me whether or not I can actually hear what's going on. This is the problem. We always have the technical issues that are just abundant with this really poor software. But until a second option is made available to us, it is the best we have. So once again, we are going to discuss today primarily climate science in all of its lovely shapes and sizes. We're going to talk about modern climate. We're going to talk about paleoclimate. We're going to discuss uh, how we know what we know, which I think is, I guess that would go under the aspect of uh, epistemology, but it's very, very important part of all the sciences. Kim, am I sounding better now? I'm not hearing you. This is gonna bring up an echo. Kim, am I sounding better? Okay, so at least I can hear myself with so I can hear that I am definitely on the alt account. I've turned off the soundbar. Let's start with the first. Well, let's start by uh, going into this, and this is always so difficult. And what I hate so much about replies, I see Kim has left. Kim will probably return, hopefully return. Because it would be difficult to do this alone, especially if no one else joins. I have to find out why this is so. Uh, Hello, Kim. Let's see if we have to. Do we need to get you back in? Invite to speak. Invite to co-host. Send co-host invite. Uh, let's start with cryosphere, which is an ongoing issue and is always part of um, replies in the space.
Hello, Sal. I can hear you much
Hello.
better now.
I don't know why, because I didn't really do anything. I didn't really change anything, but I muted the. This is not what I really want to do, actually.
What did you
Uh,
mute?
I had the alt account. Oh, damn, I hate this software. It is so. Oh, I don't know if you heard what I was saying earlier, but I had an issue with. You see, last week when I set this up using the website, it didn't allow it to be recorded, and I have no idea why. So I said, all right, fine, I'm going to go back to doing it through X. And when you do it through the X app, sometimes it mixes up AM and PM. And this is so frustrating that they write a piece of software that is designed so terribly that you can't, because if you're doing it on a smartphone, you only have a very, very small screen, and the buttons are very, very small. And
That's
there's
exactly
always,
what I have.
and it's always difficult. So it didn't let me do what I wanted to do. So let me start the day by uh, plunking in the cryosphere. And that is today's, I have actually quite a few charts, global extent for today. And that is now part of the proceedings. Um, it's the quote unquote lead has diminished slightly, but still this is the lowest amount of sea ice extent we've ever had for the 20th of February. And in fact, it's been the lowest sea ice extent for about a month now. don't have the spreadsheet open, and I don't feel like taking any risks putting it on right now. So for roughly a month, we have had the lowest sea ice extent in the satellite era history. Now, when you consider that 2023 had very low extent, 2024 had record-breaking low extent, even though back half of 2022 had very low extent. We're now in about a 3.5 year period where global ice is terra incognita. We had some low years in 2016 and 2020 and 2012, which it is kind of ironic that the lowest years always seem to be leap years. So, and I don't think it has anything to do with the with the fact that it's 365 versus 366, because they really are when they do the adjustments, they set them all as 365 days. So we have record-breaking low ice extent. We have record-breaking low ice area. Biomass came out. Let me see if I have biomass. Let me add biomass to the misery. Okay, biomass is quite fascinating. It's a little bit more
I
complicated.
was just going to ask what it is. Thank you for proceeding.
Biomass is an attempt to calculate exactly how much ice volume there is globally. So let me actually type that in. Wait, that's not global, that's Arctic. Arctic sea ice volume for the month of January. I've lost the ability to type for a second. So what they're doing is they're looking at several different parameters. Obviously, they've got extent. And you know what? Let me really go back. It's a combination of two things. It's a combination of visual methods where they actually visually say, yeah, that's 4 feet wide. And they have satellite images, which allow them to see how wide the ice is and how much of an extent the ice is. The difficult part of satellite imaging, of course, is what if it's foggy outside? So what you need to do in order to see what's going down below, if you've got clouds and fog, is you have to use a different wavelength of light that isn't blocked by the clouds. And they do that by using microwaves. So they're looking at the microwave emissions of water. And this is where it gets really tricky, because remember that clouds are water vapor. So they have to squeeze out the specific frequencies that are water vapor and that are ice and water. And by looking at several different frequencies of microwave emissions, they're able to see this is water, this is ice, this is roughly how wide the ice is. And then they also have buoys and they have sonar and they have visual identification to see all of these parameters. And they create formulas and they calculate, okay, so we have something in the realm of 15.369 thousand kilometers of sea ice, cubic kilometers of sea ice in the Arctic, average for January 2025. And that is the second lowest for any January on record. What makes this fascinating is, as you can see on the chart, this is almost a straight line plunge. There is a little bit of noise that the 2016 was the record low. And that was because there were a lot of storms in the Arctic in 2016. We don't quite have as many storms this year. What we have in the Arctic is extreme heat, absolutely crazy amounts of heat this year. Svalbard, Nuuk, Svalbard is Norway. Nuuk is Greenland. They are reporting that they have clear ocean. So, you could sail a boat right now from Svalbard to Nook. You may have to, do a little crazy little zigzag to get there. This is the dead of winter. We're just about two-thirds of the way. We're two-thirds of the way through winter. So this is roughly, and again, I could look at this and I just don't feel like popping open my spreadsheet because I'm always afraid what happens
We're sort
when I
of
switch
just
applications.
past we're sort of just past the bleak midwinter point, aren't we?
Yes, we are two-thirds of the way through winter, and we should typically be roughly. You know what? Have I even released this chart? I think I have, but I'm gonna save it and release it as a picture. I don't think I did this last week. Global. Oh, I did, but I don't. But I don't know if. Yes. What's up, Junior? Hello. I'm getting cat bombarded here. So uh, let me.
I'll take a look at your post and post them up to the jumbotron.
I'm putting. I'm gonna add it to the jumbo. Once I find the chart. Uh, Global area by day. Now, this is just a fascinating little. This is a two-part graph. The first part of the graph is in blue, and that shows you what is the global average ice extent for a 41. I should have used 40. It's okay. For a 41-year period, 1979 to 2019. I didn't want to use the last 5 years because the last 5 years is really an outlier because ice is just plunging. But I wanted to give a baseline. So this is the baseline. And blue is the absolute amount of sea ice extent. The red line, yeah, I'm just going to put it out there. And I'll do some modification to it later. Let me see. That should be out there. The red line is what is the daily change in millions of kilometers square? And that's a relatively small number. It goes from about as high as 70,000 square kilometers. Remember, that's in millions of square kilometers. So I'm telling you, 0.07. That's the highest growth rate. And that growth rate is soon. It's in
Oh,
March.
excuse me, Sal. Which
Yes.
chart are we looking at right now?
That would be the third chart. That would
The third.
be
Okay, I put a few up.
it
What color is it?
red and blue, uh, which is a nice combination because it's easy to see on a white background. That is showing us. Oh, I see. John has joined us. Abuza has joined us. I didn't acknowledge Jim and Windsor earlier. Hi guys. Uh, so this chart shows the mean daily change and the mean daily uh, amount. And the reason why this is and there is noise in the chart. That's because noise always happens. But you can't get perfection, after a 40-year time frame. On when I did this chart on the 16th of February because that happens to be one of the zero crossing dates. A zero crossing is essentially when you have no change where the daily average, that is where uh, it's flat. There's almost no change in the global amount of sea ice. And we have 4 zero crossing dates per year. That's because the North Arctic has two flats, and the Antarctic has two flats. And so when you combine them, because they're almost exactly out of sync by 6 months, which makes sense, right? You would think that Arctic ice growth and Antarctic ice growth would be exactly 6 months out of sync with each other, one going up, the other going down. So that gives you 4 zero crossings, and we just had a zero crossing, and I haven't looked. I should have done. one of these things for the last 365 days because that's quite telling. Um, but yes, this is the time of year where nothing much happens. Uh, in the South Pole, there's been no change in polar ice extent for the last like 5 or 6 days. It went up a little, went down a little. Actually went down a bit yesterday, so it's about the same level that it was a few days ago. But this time of year, and this is one of the problems. I'll get into this in a few minutes. Uh, we had almost no change in the North Pole and almost no change in the South Pole for the last week, and that's to be expected because when you're approaching maxima and when you're approaching minima, change relatively stops. So you have two maxima a year, two minima a year. It all works out in the wash. And we're still at, uh, I joke about this all the time. We're number one, which means we are the number one lowest ever uh, global ice extent. It's not as large as it used to be. We are the number one in global ice area. So let me go back and describe the difference between the two of them. When we started to do this in the 1960s, we had Nimbus satellites. They really were not as good as what we have right now up there. And so we had to say, well, we have very poor resolution. So we can get area, but it's poor, and we can get extent, and that's a little bit better. Ice extent means how much of each square kilometer is covered by at least 15% of ice. So when you don't have really brilliant imaging, but you can say, well, based on the amount of microwave emissions that we're getting, we think there's about 15% of ice covered in this 1 square kilometer. So we're going to call that extent. It's harder to get edges on area. Uh, and the amazing part about this is, let's say you have an iceberg breaking up. So once that iceberg breaks up, you're getting a lot more water hitting that iceberg. It's now the surface area of the iceberg has increased. So the overall extent has gone up, but the area goes down. So when icebergs form and then break off, you can actually see an increase in ice extent. Because again, extent means at least 15% of that square kilometer is covered in ice. But you have a decrease in area because, well, your area is only 0.15 square kilometers. So if you have a 1 kilometer chunk, and for some magical reason it would split up into six perfectly equal pieces, you would now have 1 kilometer of area, but 6 kilometers of extent. So extent, which is the easy way out, can go up while area goes down. But again, because extent is easier to measure, we use extent as the benchmark despite the fact that it doesn't give you the same level of detail as area. And then you get into the next, two phases of this. Uh, Volume is even more important because volume tells you how much ice there really is. And then you have the age of the ice, and that's harder to get. And there are ways to do it, but I don't have easy access to it, so I don't do ice age. No, no pun intended, ice age.
I
Uh,
like that. That's funny.
but
I guess having older ice would be a good sign of the health of the
yes,
ice, right?
yes, because essentially you're building ice acts as a scaffold for ice. So if you have old ice, that means that the ice has been there for a while, and it acts almost like a crystal as a seed to build more ice on top of it. Ice attracts ice. If you don't have old ice, if all of your ice is new ice, it's just formed, it can be very unstable. Uh, what is ice? I mean, ice, duh, is frozen water, but ice has the same exact temperature as water. So the way we calibrate, or used to calibrate, still calibrate, the way we calibrate thermometers is we put them in an ice bath where it has ice and it has water. And as long as you have a well mixed sample of ice and water, it's always going to be at standard temperature and pressure. If it's very ionically pure ice, that means it's really as close to like 0.999 water ice as you can get, and doesn't have salts in it, doesn't have minerals in it. That's 0 degrees. That is the definition of 0 degrees. It is where ice melts, or as water turns to ice. It takes, let's say you have a cup of water on your desk. Let's make it even exactly 1 kilogram of water. To raise 1 kilogram of water 1 degree Celsius requires 1 kilocalorie. You will recognize the kilocalorie. It's the thing that you always consume way too much of when you're going to a restaurant. Yeah. Oh, and by the way, when we talk about calories in food, it's not calories, it's kilocalories. So if you look at that package of Twinkies and it says 240 calories, I have no idea what Twinkies are.
You don't eat those, do you?
No.
Good.
But
No
I'm
one
guessing.
over 50 should eat those.
If you have a Twinkie and it says 240 calories, what it really means is it's 240 kilocalories, and what it really means is if you burned those Twinkies, it would raise 240 kilograms of water by 1 degree, or or 24 kilograms of water by 10 degrees. But then something magical happens as you reach ice temperature. As you go to 0, suddenly, instead of making that water cooler, it literally stops. And I hate to make a joke. Yeah, I'll make a joke. The temperature of the water freezes as the water freezes. Because now, instead of taking 1 kilocalorie to change the temperature of that ice 1 degree, 80 kilocalories will turn 1 kilogram of water into 1 kilogram of ice. That's a spectacular amount of energy. You're putting all this, or you're either adding or subtracting energy to reach a certain temperature. But now you need 80 times as much energy, not to make it cooler, but to do a phase change, to go from water to ice or ice to water. And when you're talking steam, it's even worse. It's 535 kilocalories per kilogram. So all of these phase changes uh, take a spectacular amount of energy. If you're warming that ice, that takes a lot of energy. If it's no longer ice, if it's now water, that same amount of energy will warm up the water much faster. So when you lose ice, you have a much greater ability to warm the water. There is this inverse relationship here. And this is a positive feedback. As you lose ice, not only do you lose the reflectivity of the ice, remember again, that ice, especially if it's snow-covered ice, and oh my God, did I have a lot of it this week. I went upstate and I helped my in-laws break the ice. Snow-covered ice is as good a reflector as you get. It can be, that's just snow-coated ice. It's about a 92% reflector.
I think John probably is feeling the effects of this today as well. But I was joking to you how it's such a bright day out, as if the sun somehow got brighter. But what it is that probably 90% of the ground is covered in snow, and some of it's ice. So it's the like the albedo is just so bright.
Yes.
You have to close your eyes. Really, I lost my sunglasses, so I've got to buy a new pair. But yeah,
The old Inuit, we have at least 1,000-year-old samples of Inuit sunglasses. They used, I think it was whalebone or seal bone, and they carved these beautiful intricate frames, and they were rounded, like the shape of an eye, and then they just did slits. So just at the dead center of the eyeball, when you wear it, is just slitted because you can reduce the light coming in by 90% and you're still fine. That is one of the amazing things that I wish I could demonstrate with a cat. Um, the human eye functions very well from between 0.05 foot candles. Sorry, let's go to the European and the ISO measurement. 0.05 lux to 50,000 lux, which is extremely bright. So you have about not quite 1,000,000 to 1 range of how well the human eye can function. So you can read, if you're very careful and you've got it in front of you, you could read a newspaper in 50,000 lux or 0.05 lux. That is 1,000,000 to 1 range. That's how incredible our eyes are able to function. And that's because of our iris. Our irises really shrink down. Humans have a round iris. Cats have an oval iris. Essentially, it has a left and a right. You all know what cat eyes look like. Cats have a left hemisphere and a right hemisphere, and they are not joined at the center. They're joined at the edges. So cats' eyes can go much deeper they can function in bright light, and they can function probably an order of magnitude lower than humans can function in the dark, which is why they're nocturnal animals. They're nocturnal because they can see that deeply into darkness, much better than we can see. So that's why the Inuit were able to survive on and hunt on the Arctic ice by wearing sunglasses well over 1,000 years ago. Hey, if we have Inuit sunglasses that are 1,000 years old, that means they probably were making them 10,000 years ago, or whenever they first started to hit the ice in North America, 14,000 and change years ago. I'm not one of those people who believe in ancient astronauts. Of course not. I
I
believe that
bet you. I bet you we could find some in some peat bogs somewhere that are probably perfectly
probably,
preserved.
probably. Uh,
But yeah, I guess it would be hard to locate them.
Oh, it's finding a needle in a haystack. Finding a pair of eyeglasses in a peat bog. Uh, but I just think that human beings, in order to adapt and to survive, we are able. We've created technology that helps us. Oliver, nice to see you. Or nice to see your icon. I don't actually get to see you. Uh, so, uh, is that a hand wave, Kim, or is that I can't tell. No, that's Liam. All right, so
Actually, I just want to say hi, everyone. Welcome to the Climate and Ecology Workshop.
Hi.
Hello.
Hi.
Hello, Oliver.
Hi, Kim.
I know you wanted to talk more about the cryosphere, and I just spent a half an hour talking about the cryosphere.
I know.
All right.
Sorry. Yeah.
There are three. I'm sorry about that. There's three charts that are up in the jumbotron. Extent. I haven't done area today because area always takes me like a half an hour to do. It's a lot more work. I have Antarctic area. I didn't do Arctic area, and combining them takes a while. But I have three charts. I have extent. I have biomass volume. So extent is volume, and then there's a fun little graph. The third one is global ice extent on a per day average, and it's got that double hump, and it almost reminds me of an analemma. I mean, it really looks like an analemma to me. Now I have to show an analemma. Uh, In blue, it's the actual amount. It goes from like 18 million square kilometers to about 27 million square kilometers. But in red is a rate of change uh, schematic. And I mentioned that there are 4 times a year where the rate of change is zero, essentially, because we hit peaks, and the peak on the northern and southern maxima and minima, minima peak, maxima minima slope, maxima slope, are there's very little change from day to day, because once you get to the to the maximas and minimas, it's just noise. So because you have two northern noise regions and two southern noise regions where the change is really not happening, that ends up having 4 zero crossings a year. This is just technical speak, where not much happens. In fact, yesterday not much happened. Although I think we still had a negative. We lost ice yesterday globally, ice extent. We are, I think, number 4 in ice extent for the Antarctic region, and we are the lowest in the Arctic we've ever seen. And this is going on about a month. We've been at Arctic record lows for ice for about a month. People have been reporting in Svalbard, that's that Norwegian island, and at Greenland that they could launch boats this time of year, and that's just insane. Yes, Kim.
I just wanted to report on the Great Lakes ice coverage. I live close to Lake Ontario. I haven't been down there. I probably should go and take a walk around. According to NOAA, the Great Lakes sit at 33.88% in ice coverage. This is about 10% below the historical average. And usually in mid-February, the ice is sitting at about 43%. Lake Huron has the highest amount of coverage at about, it's Lake Erie that has the highest amount of coverage. I think it's also the smallest of the Great Lakes, isn't it? Or the shallowest, I believe. It's at 86% of the lake is covered. So I'm not sure about Lake Ontario.
And that can actually be good for you, because the more ice coverage you have on the Great Lakes, the less lake effect snow you're going to get. So I know I actually had to discuss this today, and I had to mention to somebody who was like, "Oh, you guys always say that." I said, "No, this is how this is physics. When the wind blows over water, it picks up much more humidity. The vapor pressure of the water coming off of water is much higher than the vapor pressure of ice. So when the wind blows over the ice, it doesn't pick up as much humidity. When the wind blows over water, it picks up a lot more humidity, more water. So if you're downstream of the lake, if the lake is covered in ice, you're not going to get as much snow. If the lake is open, you're going to get a lot more snow. So the lake effect snow is worse in warm years than it is in cold years. And people don't understand this.
And
so they're
Sal,
always
to what you're saying, Lake Ontario has very little coverage, and we've gotten probably 3 feet of snow in the last week. So that goes with what you're saying.
Yeah, it can be really treacherous. And the kind of snow that we got this week, I I woke up this morning 5 o'clock and I shoveled the sidewalk. I shouldn't say that. I did not shovel the sidewalk. I swept my sidewalk. I haven't broken out a broom in about 2 weeks. Sorry, a shovel in 2 weeks. I've been brooming the snow away for the last 2 weeks. That's how much snow we've been getting.
That's not much.
Yeah. Upstate, on the other hand, we broke out the ice chippers, and we were working. I shouldn't say we, me. I was working. I did most of the work. Uh, I had to really work hard to break the ice, to open up the driveway. They have, wow, uh, about a 250-foot driveway on a variable grade. It goes from flat to about an 8% grade, and the car could not make it up their car could not make it up the 8% grade. So they had to actually have a professional come in and add mixture of salt and dead tires. I didn't know. I mean, it makes sense that they would use this, but they take old tires, they break them into a gazillion pieces, and they spray it on the salt, and that gives you traction because you're now rubber on rubber. And I think rubber is relatively uh, stable, but the problem is, oh, this is a major problem. When you're trying to go up a hill and you're spinning your wheels, you're turning rubber into dust, and that's 2.5 PM particulate, and that is one of the worst health hazards imaginable.
Yeah.
So,
And it's the biggest one too.
yeah, this is probably brake dust and tire uh, marbles. That's the actual name of this description. Tire marbles.
Would chains be would tire chains be any good for you, or is that like
well,
people don't like them because they
uh,
are
it's
hard
a lot of
wearing,
work.
aren't they? Yeah.
It's a lot of work. And I was mentioning to my in-laws that I said, you know, if this happens next year, I know it's expensive, like $400-$500 a set, but maybe get tires, get chains, because it's a lot of work. You know, you have to roll the car over and you have to tighten it. It's like, 10 minutes per tire, so it's not, instantaneous.
Do they
Yeah.
have winter tires, Sal?
I have all-weather tires. I have Michelin all-weather tires.
Nice.
They are MS rated tires. So I can use them in the summer. I can use them on the winter. The problem is they do cause a lot of tire. The friction is higher, so the fuel efficiency goes down.
Right. The
Yeah.
mileage.
But
no, I was just curious because
safety is more important.
I also have a downward sloping driveway, and my strategy is get the snow off as soon as possible to avoid the ice. I do gun it in reverse to try to get out many times, but definitely I have to put salt down and things like that when it does get icy or I can't get out of my garage.
Well, the problem upstate was my sister-in-law is she'll be actually she's coming to us. She's going to be here in about an hour or 2 hours. She has a severe injury. She's going to surgery on Tuesday for a torn labrum. So she's in a wheelchair. She can walk a little, but she's right now in a wheelchair, so she can't do the shoveling. Her husband isn't as physically able as he used to be. Their kids are not brilliant at this kind of stuff. You can have able-bodied kids, but you have to motivate them to do it and to give a damn and to do it well. So they didn't do it well. And as a result, the driveway was not properly cleared. The walkway to the house was not properly cleared. So we were going up there anyway. So I didn't go up there to shovel snow, but it was just a consequence of it.
We well, this is a little bit of an aside, but I'll just, if you don't mind me saying, I think,
Sure.
I, myself included, we're guilty of raising entitled children. I do most of my shoveling, and also the people across the street, even though they've got, one son doesn't live there anymore, but I think the 22 or 23-year-old son does live there. I've never seen him shovel the driveway. So, I remember shoveling my grandmother's driveway when I was like 8 years old and helping grandma. I mean, probably because there wasn't a man around. She was widowed and I spent a lot of time over there. She took care of me. So I was like helping grandma out. But I think, in a way we're harming them because we're we're just letting them go off and play video games and do stuff like that, and they're not learning and also feeling good about contributing, right? Because actually it felt really good to help out.
Is there an app for snow shoveling?
Yeah, right. Oh,
exactly.
The only problem is if there were an app for snow shoveling, you would probably have a problem with hitting the AM/PM button because you wouldn't know if you were setting it to AM or PM.
Yes.
I want to get into the main topic, but I want to do it a quick anecdote. This goes back about 25 years. I'm driving down the Sawmill River Parkway, going to the exit, going to Gun Hill Road, and I see on the side of the road these two guys, probably about 20, 21, 22. They're in shorts, they're in sandals, and the cops are changing their flat tire because these two young adults didn't know how to change a flat tire.
Oh, that I've got one to add. Go. Sorry to cut you off.
Yeah, and what I was going to say is I was working in my father's car when I was about 12 because he wanted me to know how to do it.
Right. And you love cars now.
Well, yes and no. Yes, but when you work on something, you do develop an affection for them.
Right.
Getting your hands dirty adds to the joy of ownership. Believe it or not.
Yeah, we have to take the time to teach young people. I mean, my son can do a bit of gardening. He can mow the lawn, and he can definitely shovel snow. What I wanted to share was I love tennis, and a few years ago, it was at one of the Grand Slams, and I think the player Alexander Zverev, let's say he was about 23 years old at the time, he broke his shoelace. And he had to change his shoelace, and he had no idea of how to do it. And he was kind of looking at the referee, who happened to be a female referee, like, can you help me out here? And she was just kind of laughing at it all. And it was like, 5 minutes later, the shoelace still wasn't in the shoe. But another tennis player, they were making light of it, and he said, "Of course, we don't know how to change our own shoelace. We're tennis players. We've got people doing everything for us."
I think seriously, the best way to do it is just at that situation, get a scissor and just literally snip down the center. So you take all the pieces off as quickly as possible. That probably cuts the amount of time. Obviously, you're destroying the old one, but who gives a damn? That probably cuts the amount of time by 80%. Because it takes you longer to remove the old one than to put in the new one. Because you always have to get through those eyelets.
That's true. Very true. It's tricky.
All right, so let's get to the main topic, and this is a big one. I was joking about this being like the first time I've ever actually printed out a checklist for myself of all of the needed information. So we're going to do this in two parts. We're going to do the first part. I'm going to do the first part of dynamics of modern climate, and then Kim is going to do her piece on climate psychology, and then I'm going to do the rest of it. So this way we break it up into actually it's 2.5 sections, but we break it up into my presentation is in 2 sections. Her presentation interrupts it, gives us time to think, to understand. So here we go. The dynamics of modern climate, and I'm going to break this into 4 sections. You have thermodynamics and radiation physics. That's the first section. I'm going to read these off quickly, and then I'm going to do deep cut. We have atmospheric studies. We have solar studies, the physics of solar fusion and solar evolution. And then we have the big one, solar system dynamics, orbital and axial tilt studies. And later on, I think I might as well add to the today's discussion. The asteroid seems to be much more benign right now. It looks like we're not going to get killed by a 100-meter long rock in 7 years. So the first part of and to preface all of this is I got into the usual conversation with a denier. Uh, and you know how they always say, oh, well, the only reason people are studying climate change is because of there's so much money in it, and it's good money to, to show that uh, they only give results because they're paid to give results. But the fact of the matter is, when it comes to the money spent in climate science, most of it is not spent on modern climate science. It is spent on paleoclimate studies. Most of the money that they spend on climate research is looking at what happened in the past. And obviously, humans didn't have a bearing on what happened in the past. When we spend $500 million on a research grant to do deep paleoclimate research for the last 500 million years, we're not looking at what's happening now. We're looking at the world beforehand. And because you want to know, humans are naturally curious. We want to know what the past was like. We want to know what made us what we are today. How did we get here? So that's why most of the money spent on climate is spent on paleoclimate. So getting back, the first section is thermodynamics and radiation physics. And I should punch up, but I don't have it in front of me right now. Uh, in the last few years, we've had some major research done on exactly what we can see. So we have uh, lasers were scanning the skies for local CO2 content, and they were able to measure very precisely how much CO2 was in the atmosphere. And they were also able to measure how much upwelling IR and how much downwelling, upwelling means going up IR, and how much downwelling means coming from the sun, visual light there was. And they were able to see by doing what's called a time series, where you see how much you have today, how much you have the next day, how much you have the next day, and so on and so on. So over time, you see the patterns, and that they validated that indeed, as the amount of CO2 light that our planet is giving off. 220 Kelvin to 320 Kelvin. When it's at 320 Kelvin, it's almost, let's call it for argument's sake, it's 50% more. So it's not giving off 50% more light, it's giving off over 4 times as much light. So there's is a big difference between how much energy that that is between the amount of heat that's coming from the poles and the amount of heat that's coming from the equator. But we can measure all this because we have these wonderful satellites that are in space that are circling the Earth every 10 days roughly. And every 10 days, they hit a different part of the planet from pole to pole. It's slightly rotating. So you do a small slice of the planet every 10 days, and they average all that out, and then they figure out what happens from month to month. So the thermodynamics of climate change is extremely important. And what the first thing this teaches us is the sun doesn't actually do that much to control the climate. And I know that that's the whole idea behind this account, the Cycle 25 account is to discuss was originally almost like a parody because I if you ever read my pinned like 28 post series, uh, I'm saying, well, is the sun actually causing climate change? And the answer is, after like 20 tweets, you get no, the sun is not causing climate change. Uh, clouds, cloud changes do cause climate change. Ice changes definitely cause climate change. The darkening of the lithosphere causes lithosphere means ground causes climate change. So when we take forests and pave them over in asphalt, it changes climate because you make the planet darker. So there's all of these secondary effects, and learning the physics behind it is part of the physics of climate change, part of discovering climate change. The great thing about a lot of these, the first chapter of this discussion is these are relatively easy things to measure. These are relatively easy things to discover, and this is classical physics. There's no, this isn't quantum physics. This doesn't even go into quantum chromodynamics. This is just basic classical physics. The next part of climate science is atmospheric studies, and it is it goes hand in hand with the thermodynamics because we're learning how different molecules react and how they affect the amount of light passing, IR passing through into back into space. We keep on refining. Every few years, there are slight microscopic changes to how N2O and CH4, how nitrous oxide and methane change uh, over time as the concentrations build up what it does. Going back to 1896, when Arrhenius did his first Santi Arrhenius, um, uh, a little historical footnote, that is the great grandfather of Greta Thunberg. So she comes from a long line of climate scientists, although she's not a scientist. And he said he was the first one to state that the concentration of CO2 in the atmosphere is going to affect the amount of light absorbed based on the logarithmic amount of CO2. So it's not linear. Actually, let me go back. Early on, when you're 1 ppm, 2 ppm, 3 ppm, we're at 427 pretty much. I think 427.05 was this week anyway. When you're only, 1, 2, 3, 4, 5 ppm, it is a linear equation. And then you start to reach a point where it's no longer linear, it's logarithmic. So once it's logarithmic, what that means is if you double the amount of CO2, each doubling has the same effect. So going from 100 to 200 has the same temperature effect as going from 200 to 400 has the same temperature effect as going from 400 to 800. So each additional molecule has less impact than the one before. That doesn't mean that it ever saturates. And this is another one of the great denier points that we have to constantly combat. Oh, CO2 is saturated. No, it cannot saturate. By definition, it is a logarithmic function. It will never saturate. It will just keep getting smaller and smaller asymptotically, but it will not saturate. And if
Sal, he'll probably come back. This usually happens once a space. There he is. We lost you for a moment, just a moment.
Just about the 1 hour mark. So I was talking.
Right.
I was talking about saturation. How there is no saturation. It doesn't happen. There's nothing you can do about it. Despite what the deniers are always saying, it's just that each additional molecule has a less effect than the molecules beforehand. In the last few years, we have refined to a much greater extent. Oh, by the way, the last paper that I reference is the 2000 late 16 Ekinen and Meyer paper that calculates the forcing function of CH2, CH4, CO2, and N2O. John Callender, Guy Callender, what am I saying, John? Guy Callender did his equation in roughly 1937, 1938. I mean, when he published it and when he did the equation may not be the same year, but anyway, let's call it 1938. And his equation from 1938 is pretty much unchanged. Yeah, we've worked out a little bit of the kinks. We've gotten a little more accurate, but it's almost exactly the same thing. It's within plus or minus across the entire spectrum, like 100 ppm to 10,000 ppm. It's off by less than 4% of what he said in 1938. So just think about, how extraordinary his paper was that he was able to nail it that far back in time, uh, 85 years ago and change. He nailed it. It is still accurate today. But methane and nitrous oxide has changed significantly over time as we do the studies because, we have better instrumentation. I should also mention that in the past, before Keeling and the famous Keeling curve in Mauna Loa, what he did that was so extraordinary wasn't just setting up a lab, but he, instead of doing the old wet flask titration method of figuring out how much CO2 is in the air, and that's wet chemistry. So it's very time consuming. It's very expensive. Taking each sample is a pain in the ass. He invented the infrared system, where essentially you have an infrared source and you have two um, sensors, and you have uh, what you call it. You have a vacuum to one sensor, and you have open air to the other sensor. So the light is emitted by the source. It measures the two different uh, amounts of bandwidth pass through to a vacuum sensor and a sensor in air. And then it says, okay, based on the ratio of how much the vacuum sees versus of how much the exposed to air sensor sees, we can calculate to a fraction of a ppm exactly how much CO2 is in the air. And we can do it real-time basis. Instead of taking hours to do an assay, it's done immediately. And instead of maybe plus or minus 20% accuracy for the old wet flask methods, this is again immediate, less than a fraction of a percent accuracy. So the world changed when he invented the electronic method of determining how much CO2 was in the air. And literally right after that, it was like bang, bang, one after another. They're able to do sensors of different types, and you have multiple sensors that one device can measure because it has a large frequency range. It can measure multiple different uh, atmospheric constituents. Of course, then there's the older techniques like gas chromatography, where you burn something, and then by looking at the color of the flames, you figure out how much of each material is in it. So this is essentially similar to that, but it's much easier because you're just shining a light, so you don't have to destroy the sample, and you don't need to use as much energy, and it's much cheaper, and you don't need to have that much more the equipment. I think you can now buy a very cheap, I would definitely not, bet my life on it, but you can get a CO2 meter for $10. So yeah, let's say it's plus or minus 2 ppm, 3 ppm. That's still pretty amazing for $10. Will it last 5 years? I don't know, but it goes to show how the price for this equipment has completely plunged because we, are able to do it with much simpler means. We don't have to use chemistry. The next part of climate science is a lot trickier, and it's part of what I did for a living for 30 years. I did solar research. We had a bank of meters on our roof, and we analyzed the visual spectrum of sunlight, and we looked at how much sunlight was passing through the atmosphere every single day. These were solar studies of how, and this was not done for climate purposes. This was done because the company I worked for created devices that turned roadway lighting or home lighting on and off based on how much light is out there. So when it's dark, you turn the lights on. If it's when it's in the morning, when the lights come back up, you turn the light off. The company I used to work for was one of the leaders in roadway lighting equipment, and so we had to know how much light was coming in, how much sunlight was in the ambient area to test all of our devices, which is why I went into solar science. I did have a little bit of a background in university of astrophysics and solar physics, but it was like a small background. I mean, I took a few courses, but it wasn't huge. But so, my boss, when I talked about it, that I said, yeah, I used to do that in university. He was like, great, you got the job. So we used to have a consultant who would do it, and so it became my full. It wasn't a full-time job, but it was my job. Uh, in the last, I'd say about 70 years, we went from just looking at little tiny, the images of sunlight to now we have catalogs of several 100 million stars in this galaxy. And we see their life and death. We see how they change over time. We see their color. We see how if they're variable or not. And by looking at all of these stars, and especially by looking at the general frequency, we know how hot these stars are. We know how old these stars are. We're able to figure out how solar evolution works. I wish I had prepared a chart for this. I'll throw it in later on. But we know based on the temperature of our star and the size of our star, how long it's going to last before it goes. It's probably going to be nova. It's not going to be supernova. It's too small to be a supernova. But in about 9 billion years, this sun is going to just expand beyond the point of maybe even the Earth's distance, and it's going to turn the planet into a cinder. But long before that, there isn't going to be any life on Earth because in about 3 billion years, the temperature will become so great that it'll be impossible for water to be anywhere on the planet. And in about 1.5 billion years, it will be impossible for water to be in the oceans. So we are time limited. So make the best of the next billion years. If we don't kill ourselves before that, this is how much we have. And over time, we have discovered that our sun is extremely special. It is one of the least variable suns we've ever seen. It's like, that's why life, I guess, forms so readily and easily on Earth. It's because we have a sun that doesn't, catastrophically blow off 10% of its volume and then just, literally wipe every piece of life off the surface every few million years. We don't have a binary star. Binary stars are terrible because eventually what happens is, as over time, one star gets smaller, one star gets bigger, one star draws energy out of the other star, and eventually you go supernova. But before that, you might have several instances where again, you it sucks in more and more hydrogen and helium from one star, sucks in more from the other star, and eventually it trashes itself. I'm going to just go very, very quick on this. The size of a star is a constant battle between expansion and uh, uh, gravity. Gravity wants to make that star as compact as possible. Of course, it wants to bring everything together. But the heat, the heat is random motion. The heat in the sun's atmosphere wants to set it apart. So there is this battle between gravity trying to turn it into a black hole and expansion trying to keep it the same size. And expansion wins. Expansion wins until you reach a point where you have no more hydrogen left to burn. And then you start to burn helium, turning helium into carbon. Then you get the CNO cycle. And then eventually you lose all the hydrogen. And gravity wins, the star compresses, the hydrogen expands, and you get a nova. You get that gigantic compression. That compression expels out the remaining hydrogen and some of the other molecules. And if it's atoms, and if it's a supernova, you have a solar furnace that is now creating all of the molecules heavier. I keep saying molecules, all of the atoms heavier than iron. Iron is this amazing sweet spot, and it's not exactly, the end all be all, because you do have, it's just the statistics of nuclear fusion. But the sun will keep burning until you reach, add another nucleon here. So you throw another proton in there, throw another neutron in there, and it gets bigger and bigger and bigger and bigger until it hits iron. It can go beyond that, but everything over iron wants to, over time, get nuclear decay and go back to iron. So iron is, I think it's 26, is this period of stability in the periodic table where anything heavier than that wants to go back to iron. Another cute little reminder, if an isotope is even numbered, isotopes are the number of protons and neutrons in the nucleon. If it's an even number, it's almost never radioactive. If it's a odd number, it is radioactive. So that's why that's just why you can, if you have to know which is the dangerous one, uranium 235 or uranium 238. 238 is the safe one. because it's an even number. 235 is a dangerous one because it's an odd number. So we've identified that we have this very stable star, and we've identified that it is, we have a long time to go. But there is a constant increase in the energy that stars give off. And it's at this point in time, it's roughly like adding 1% every 105 million years. So we have to ask ourselves, how was the Earth hotter 400 million years ago when the sun was 4% weaker? And that's kind of, this is called the cold Earth hypothesis. The cold Earth, not dilemma, but anyway, we don't quite know why the Earth was warm. And one obvious answer is there was a lot more carbon dioxide in the atmosphere. And the other answer is there was a lot more methane in the atmosphere. So life formed, the Earth warmed because it had more greenhouse gases in the past. And life has, I'm actually jumping ahead, this is really paleoclimate. Life takes the energy in carbon molecules and converts that into water and oxygen. And by doing that breakdown, it changed the atmosphere from a very high greenhouse gas atmosphere to what we have today, which is relatively low amounts of greenhouse gas. I don't want to go Gaia on everyone here, but it is kind of Gaia that the planet over time, as the sun gets stronger, the atmosphere reduces the amount of greenhouse warming and has given us, for billion years, a relatively stable planet. And that's again paleoclimate, so I'm not going to go into that. The final part of the modern climate research that we do is to discover how the Earth's orbit changed over time. And yes, this is paleo, but it's also modern climate because we need to know, what's going on. And the first concepts behind this came from like the 1880s, where scientists were saying, it does look like this orbit cannot be perfectly stable. It does have to change over time. Uh, Milutin Milankovic. This is a difficult name to pronounce and spell. You'll notice that I'm probably the only person on Twitter who likes to use his Serbian spelling. So when I came
I was just going to ask if he was Serbian or not. I thought he was.
Yes. I'm like the only guy who uses Milankovic with the accented C as opposed to ITCH, which is what everybody else uses. Because I have respect for his heritage. So anyway, that's not important. And he came up with the mathematics of all of this. Okay, back then, when he started, he only had, I was about to say 8 planets, but he actually had 7 planets and Pluto. But Pluto hadn't been discovered at that time. Let's still call it a planet, even though it's not a planet. At least it's no longer the modern definition of a planet because of its size is so small. And every time we made another discovery, we were able to improve the long-term calculations for how the other celestial bodies in our solar system pull and push the Earth. And these are really crazy calculations, but hey, they were doing them with slide rules in the 1920s. And even back then, they had a very good idea of what was happening to the Earth over the last 100 million years. And they started to, when they did paleoclimate research, and again, that's paleoclimate, so I shouldn't get into it too deeply. They started to discover that the natural melancholic cycles were in lockstep with glaciation and deglaciation in the last 3 million years. So a great deal of climate science research is to discover how not the changes in the sun, but the changes in Earth's orbit dictate what is happening to our climate. 72% of the world's land is in the northern hemisphere. And it gets even worse than that when you think that Antarctica is like a quarter of all of the land in the southern hemisphere. And Antarctica is literally a world of its own. It's just completely crazy climate compared to everywhere else. So most of the temperate land, and yeah, and it is funny that I think I've mentioned this a long time ago, that there is so little of planet Earth that is antipodal. An antipode are two sides of the world and completely opposite sides of each other. Essentially, if you drew a line from one to the other, you would pass through the center of the Earth. That's what an antipode is. There is incredibly little land on Earth that is antipodal. It's just worked out that way. I mean, it's just crazy. Maybe there is a mass dynamic with the plates that makes it harder for antipodes to occur. That's speculation. And yeah, I guess you could say that is also part of paleoclimate. But because most of the land is in the northern hemisphere, and land warms up much faster than sea does. The air over the land warms up much faster than the air over the sea does. Our climate is pretty much dictated by what is happening in the northern hemisphere. So when the northern hemisphere sees more sunlight, the planet warms faster. When the northern hemisphere sees less sunlight, the planet doesn't warm or cools. And we're in a very interesting point right now. Part of the Milankovic cycles is I love this name, the precession of the equinoxes. It's such a flowery, beautiful expression, and essentially what it means is the way the equinoxes, the vernal equinox, which is the spring, and autumnal equinox, which is the summer. Equinox simply means when the sun appears to be directly over the equator, because the sun is constantly moving. And there's another aspect I'll get to in a minute. So the sun is trying, is constantly changing where it is. Right now it's 24.44 degrees. And when we were younger, it was 24.45 degrees. So it's changed slightly. This is called axial tilt. That's how far uh, how far off of the normal the Earth's rotation is. If you ever, you get a globe and you see that the North and South Pole are on an angle to each other. They're not. It's not straight up and straight down. The globe is tilted by 24.4 something degrees. Uh, that is how the Earth spins. The Earth can spin anywhere from like 21.7 to 25.5, and we're right now near the low end of that. Every 25,877 years. I can't remember all these things. Too many numbers. Uh, the precession of the equinoxes changes, and right now we are close to the sun on January 5th. So it just passed 6 weeks ago, where we were at the closest to the sun. When the southern hemisphere is at the closest, when the southern hemisphere summer is close, the Earth cools down. When the northern hemisphere summer is the closest, the Earth warms up, simply because, again, most of the land on Earth, 72%, is in the northern hemisphere. So the more light the northern hemisphere sees, the warmer it is. So I mentioned the equinox and I mentioned the axial tilt, but the real driver of climate is eccentricity. And I'm going to get to eccentricity later when I talk about the asteroid that's thinking of hitting us. Eccentricity is how out of round your orbit is. So the Earth is orbiting the sun, and it's not a quite perfectly round orbit. It varies from 147 point something to 152 point something million kilometers. The difference is roughly 1.66%. We have an eccentricity of 0.0166. That can go from almost zero, which means an almost perfectly round orbit, to about 0.55%, which is a really stretched out orbit. When it's a really stretched out orbit, you get a huge difference between winter light and summer light. And not just, because winter and summer, the seasons in Europe, if you were on the equator, you would see a lot more light, obviously, when you're closest to the sun than when you're the farthest away from the sun. Bearing in mind that this is a square, the equation for how much light you see is based on the radius squared. So, I don't want to do the math. If you're 5.5%, it's not closer on one part of the year than the other part of the year. It doesn't mean you're getting 5.5% more light. You're getting like 14% more light, or whatever it is. Probably more like 12% more light. So you're getting 12% more light when you're closer to the sun than when you're farthest from the sun. That's a huge amount of difference. And this is probably the primary cause of natural climate change. At this moment in time, because we are at a relatively mild 1.66%, and we are at a relatively mild axial tilt, a favorable axial tilt, we should be getting cooler, and we should have been getting cooler for like the next 6,000 or 7,000 years, and then it would slowly start to come up. And because we're approaching this extremely unique event where we have almost no no eccentricity in about 50,000 years from now, from 50 to 150,000 years, the Earth's climate would be extremely mild in the near future. So the changes that we are seeing, where we're getting northern hemisphere land has gone up about 2 degrees Celsius in the last 40 years. We should be cooling. We're not. We're heating at rates that we have never seen in the paleoclimate history. This is how we know that this is not quote unquote natural. This is has other reasons for being here. We know the atmospherics. We know the how the ice has changed over time. We know how the Earth's rotation has changed, and we know the sun is, unchanging pretty much for all practical purposes. This is how climate science knows that modern climate is being extremely influenced by anthropological changes, anthropogenic changes, rather than natural changes. And I guess this is a nice place to end the first part of this discussion. Great time to ask if anybody has any questions. I just gave you a lot of information. This was, I don't know, about 20 minutes long. So does anyone have any questions before Kim?
Can you explain to me, Sal, about doubling? I know that Man goes on about it a lot in regard to rising sea levels and so on, rising ocean levels. He got very enthusiastic about the doubling in order to explain how, as he put it, it was the oceans were going to rise some phenomenal amount, 33 feet in the next 75 years or so, if it's business as usual with fossil fuels. It seems like a huge rise, but then he was going on about the doubling effect.
Well, the doubling effect is the way that every doubling of CO2 has essentially the same temperature change in the short term. In the short term. In the long term, you start to get differential feedback effects, because in the long term, you get ice melt, you get different cloud formations, you get water temperature. Again, as I mentioned forever ago, it takes 80 kilocalories of energy to turn a kilogram of water into a kilogram of ice into a kilogram of water. If you've done that, the next 80 will turn that kilogram of water into 80 degrees hotter water. Obviously, that's not going to happen. But it just goes to show that it's not quite a tipping point. But once you get rid of all of the ice in the oceans, all hell breaks loose. You still have land ice, but once you get rid of all the ice in the oceans, then every watt per meter square, which it's like, what is it, 4, it's the other way around. It's like 0.25, so it's like a quarter of a calorie per square meter. Once you get rid of that ice, it's just so much easier to heat up the oceans, and it becomes so much easier then to heat up the land and heat up the air. So that's the long term. That's not the short term ECS of climate change. That's the long term ESS of climate change. Yes, Kim.
Hi. Just wondering, with the talk about heating up over land and the ice melting, have you read any studies about what in the long term, like let's say hundreds of years from now, or maybe even thousands, if we don't do anything and there is a whole bunch of runaway feedbacks and the temperature keeps on increasing, is there any idea, like, if the bodies of water could start evaporating and disappearing?
Evaporation takes a lot of energy, and again, because what will happen, and we're seeing it happen. Maybe I can find that and plunk that in quickly. Throw up a map. Let me see if I have precipitable water. I should have a recent precipitable water somewhere. The atmosphere has the capacity to store more water in it, the warmer it is. Water, of course, means clouds, but water also means water feedback, because water is a greenhouse gas. It's just a condensing greenhouse gas, which means it comes out as rain. So I just added to the jumbotron. I didn't add it to the jumbotron. I added it to the wrong one. So let me go back and do that for the second time. Precipitable water, as it's actually changed quite startlingly. 2024 had about 2% more precipitable water than any prior year that we have seen. And 2023 was a decent chunk above 2016 was the previous high. So I'll just put that in there quickly. It's now on the jumbo. In terms of kilograms of water per square meter, that is essentially the entire water column in the atmosphere. It's gone up from a record high in 2016 of 25 kilograms per every square meter to 25.76 kilograms per square meter. So that's 3% more water is in the atmosphere now than the prior record. So that's gonna come down eventually. But it's warming up when it's staying up, and when it comes down, it turns into water. It causes flooding. It causes all sorts of dynamical turmoil in the atmosphere, more wind, more hydrological issues, more ice melt. Deirdre, good. Well, to hear morning. Actually, I'm about to, no, I'm past noon here. Wow, how time flies. Hi Deirdre, what's up?
Hey there. I just wanted to point out, as far as the climate equilibrating, there's actually a really interesting bifurcation that some nonlinear dynamicists noted in the climate. And there's like a step increase in temperature as the poles melt in a transition to what's called an equable climate, where it's not much colder at the poles. I was just trying to find it. But when Kim asked the question about what happens long term, that's what happens long term. We transition to an equable climate, and it's a major transition. But that might be why one of the reasons why there was a study that found a really high equilibrium, high climate sensitivity, and it's because they were fitting across this Hopf bifurcation. It's a nonlinear dynamics concept where there's a sudden nonlinear response. The Amok tipping point it's also called a tipping point. Although tipping point's a little more general, but the Amok tipping point is another example of a bifurcation. So I'll try and find that study and share it.
This is okay. This gets seriously into climate science here. It makes sense when you understand it. As you go higher, the atmosphere thins out. As the atmosphere thins out, you have less air. You have less ability for the air to absorb upwelling IR. Antarctica is like 3,500 meters high, average, and most of that are ice mountains. So as those ice mountains start to melt, the atmospheric pressure is going to rise. As the atmospheric pressure starts to rise over Antarctica and over Greenland, you get more global warming. So you get this feedback effect: is less ice, more warming, less ice, more warming. That is just being derived by the fact that the atmospheric pressure over those areas is going to rise. And that is where you get into the feedback loop where I don't want to say tipping point, but that is where you can tip point, because you reach the point where just by doing nothing, it's going to feed back forward, and I guess that is what a tipping point is. That when you no longer do anything, you still get the effect. So yeah, that is one of the bifurcations. Is once you know when you're at the point where you're no longer seeing only a tiny bit of change because you're 4,000 meters above sea level, and now that you're 1,000 meters above sea level, and your air pressure is, instead of 300 millibars, it's now would be about 500 millibars. You're now, instead of 500 millibars, you're now at 1,000 millibars, and suddenly you've got twice as much global warming because you have twice as much CO2 and you have twice as much atmosphere.
If I could say something a little further, so this was done with a simple Earth balance model, but it was fascinating that the equilibrium climate sensitivity at the tropics was much smaller than at the poles, at the Arctic and at the Antarctic. And we might have seen a tipping point or a sudden step change in Antarctic sea ice recently. and there was a study. It found it had to do with a change in air circulation. There's a Antarctic polar vortex expert, but when we had that enormous anomaly in the Antarctic last year, she published it. I'll try and find it. But the interesting thing is our global climate models don't adequately capture what's happening at the poles. And it's one of the reasons I follow, I forget her name, they call her the prophet of the polar vortex, which is at Woods Institute. But she and Judah Cohen published this paper, and it's like, we're really not capturing what's going on in the Arctic. And so that's a big kind of known unknown right now about climate modeling. So
Yes, that is, yeah, that is part of it. We're going into terra incognita here. We are seeing things that they're doing things we haven't expected.
I think her name is Francis. It might be Jennifer Francis.
I'll search for it. So, are there any more questions on this topic? And if not, then Kim has the floor. Kim, are you with us?
Well, Sal, I am. You did a fantastic job. Thank you for always educating us so we can explore about climate science and earth science. I want to talk about how we think, feel, and relate to the climate crisis as sort of an introduction to climate psychology. It is now widely accepted that facts and information about the risk of climate change, taken alone, do not promote change. There is a growing acceptance that the climate movement could be enriched by incorporating deeper psychological perspectives. Confronting the reality of the scientific evidence without shutting ourselves down emotionally is difficult. We need to find ways to be present in our situation and allow space to express climate distress without becoming so overwhelmed that we are unable to act or to talk about it. To this point, Dr. Mann advocates that there is an urgency to use our agency to create change. Part of this problem is that the facts have been infused with political beliefs that muddle both the climate science and the solutions to our planetary crises. Gerald Cutney speaks about this in his book, Climate Denialism in America. As far back as the 1960s, the fossil fuel industry commenced a propaganda campaign to create doubt and confusion over the validity of human-caused climate change, and employed scientists and funded the political campaigns of the Republican Party. This highly organized administration of doubt was able to shape how many Americans, Canadians, and Britons feel about the climate crisis and think about the climate crisis. Somehow, ideas about freedom and self-determinism have become wrapped up in whether or not we as a society should fund fossil fuel companies and or whether the government will, with our tax dollars, support a renewable energy infrastructure. In relation to this, I recently watched a video of the Florida Governor Ron DeSantis, filmed with a backdrop of Texas oil wells, claiming that green legislation is all part of a left-wing scheme that will try to limit your choices as as Americans, while at least the way I see it, in reality, it is the Republican Party that is limiting free speech and free choice. Last year, Florida's Department of Education approved climate denial propaganda to be taught to school children between the ages of 4 to 11. Some examples of this propaganda are the following statements. Wind and solar power pollute the earth and make life miserable. End quote. And that climate change is completely natural. He also deleted climate change from Florida's policies and stopped programs designed to encourage renewable energy. Trump's latest executive orders eliminate the choice of energy source by removing the green infrastructure funding. There's even appliances have become partisan issues. Let's see, there was a bill that was introduced, I think it passed the House, but it didn't pass the Senate, called, quote, the Hands Off Our Home Appliances Act, end quote. This act would make it harder for the Department of Energy to regulate new energy saving standards. This deepening polarization of the ways to cut CO2 emissions and limit the climate crisis is reflected in people's attitudes towards the planetary crises. According to the Pew Research Center, 4 years ago, 84% of Republicans supported new solar farms. By spring 2024, support for them decreased to 64%. This downward trend for decarbonizing initiatives is also seen in public support for EVs. Only 29% of Americans said they would possibly buy an EV in 2024, down from 38% in 2023. But American belief in the climate crisis is not subsiding, at least not according to the Yale Program for Climate Communication. They did a survey, which I put some of the graphs up in the Jumbotron there, about climate change in the American mind, beliefs and attitudes from fall 2024, and this was reported on February the 13th. They found the following social trends. This has like an accuracy of about 95%. And the survey size was 1,013 people across America. The key findings were Americans who think global warming is happening outnumbers those who do not by a ratio of 5 to 1, 73% versus 14%. 60% of Americans understand that global warming is mostly human caused. By contrast, 28% think it's mostly caused by natural changes in the environment, which is still a fairly big number. It's basically almost 1/3 of Americans. 57% of Americans understand that most scientists think global warming is happening. By contrast, 21% think there's a lot of disagreement among scientists about whether it's happening or not. 64% of Americans say they are at least somewhat worried about global warming, and 1/3 of Americans say they're very worried about global warming. 48% of Americans think people in the United States are being harmed by global warming right now. And 49% say they personally experience the effects of global warming. Majorities of Americans think global warming will harm plant and animal species, 70%. The world's poor, 68%. People in developing countries, 68%. People in the United States, 63%. People in their community, 53%. And their family, 51%. Many also think they themselves will be harmed, 46%. A full 11% of Americans have considered moving to avoid the impacts of global warming. We also have 66% of Americans thinking that global warming is affecting weather in the United States, including 35% who think weather is being affected a lot. The majority of Americans think global warming is affecting many environmental problems in the United States, including extreme heat, 77%, wildfires, 74%, droughts, 73%, flooding, 72%, rising sea levels, 71%, hurricanes, 71%, air pollution, 68%, water shortages, 67%. Even reduced snowpack is at a high of 65%, tornadoes, 65%, water pollution, 63%, agricultural pests and diseases, 61%. Let's see. Okay, let's move on to, okay, so this is important. So it seems overwhelmingly that Americans, the majority of Americans, believe that climate change is happening, that climate change is human caused, that climate change is harmful to them and their communities. But in terms of Americans being willing to socially engage with global warming, there seems to be a disconnect between what they believe and how they are willing to act. 62% of Americans say they rarely or never discuss global warming with family and friends, while 38% say they do so occasionally or often. I think, I'd like to get back to this point because I think it's really important to talk about it. 37% of Americans think it is at least moderately important to their family and friends that they take action to reduce global warming. And 36% say their family and friends make at least a moderate amount of effort to reduce global warming. Of course, it's questionable what people perceive a moderate amount of effort to be, and some people think it means they recycle, which really does nothing to limit global warming. 47% of Americans say they hear about global warming in the media about once a month or more frequently. Viewers say that they hear about global warming on social media once a month or more often, 27%. They're obviously not on my Twitter feed or probably any of our Twitter feeds because I see global warming stuff every day, all day, 24/7. Let's see. Okay, 65% of Americans say the issue of global warming is either extremely, very, or somewhat important to them. And 31% of Americans say that they have rewarded companies that are taking steps to reduce global warming by buying their products. Clearly, there's a disconnect between our beliefs and our behavior. Even when people are able to look past the political distortions of climate science, the vast majority do not change their behavior to bring about change. Why not? Climate psychologists argue that our inaction is because of the enormity of the problem. It is very existential. Its very existential nature makes it emotionally difficult for us to deal with, and and at the and at once at the individual level confront and accept the dire implications of climate breakdown. So what happens is that we shut down. Part of our solutions to this have to involve overcoming the human tendency to turn away from that which is painful. Quote, when people become climate aware, if they are not part of an engaged community, feelings of powerlessness can easily lead to frustration, despair, and depression, end quote. And this is from the Climate Psychology Alliance. People's ability to act is shaped by the scientific and political complexity of the climate crisis and by the diversity and politically value-laden solutions to it. Our high carbon lifestyles are in a sense locked in by social influences and material structures. Considerable self-determination is needed to behave in opposition to social norms. For example, driving ICE vehicles, eating meat, using chemicals, or using chemicals on your mowed lawn, keeping up with the Joneses. But this social cueing of peer pressure has another side of the coin, the one that values nature over consumption, community over individual. Even having this space creates a forum for people to feel comfortable and to talk about climate change. This is a climate solution. Just by being able to talk about how we feel about it counters social isolation and makes it a little less overwhelming. We need to be conscious that we require a melding of humanistic support grounded in a recognition that we are dependent on a healthy planet and its various ecosystems to survive and thrive, and that we should be guided by the facts of science and local traditional knowledge. Let's see, just as supporting each other's agency by forming a group of climate ecology aware global citizens helps, we are also fighting climate denial by refuting their claims and by being a forum for explaining and exploring climate science and ecological research. Remember, denial is not ignorance, and to deny something, we must first have seen it as real. Many people now accept climate change, but they disregard its significance. Psychological and sociological theories of denial have been used to further our understanding of this. Freud in 1925, he wrote about two types of denial: negation, when something is repudiated as not true, not there, not happening, and disavowal, when something is known but treated as unimportant. Disavowal is a term covering a complex set of ways of minimizing felt emotional disturbance caused by facing reality. It can even enable a person to deny and acknowledge climate change at the same time, but with different parts of the mind. Disavowal, it becomes implicit because it's where the facts are recognized without any consequent responsibility to act on them. It enables people to avoid feeling disturbed and hence responsible for their actions. I think these are the type of people that we have to try to reach out to, the people that they're not in denial, but they're in disavowal. Disavowal can assume many different forms among individuals. It mainly involves an acknowledgement of the negative effects of certain behaviors, but acting as though on an individual level our actions are of little consequence. For example, understanding that a high carbon lifestyle is contributing to the climate crisis, but refusing to make any changes in our personal lives. I think I might just a little bit more about disavowal. Zeri Bavel in 2006 saw everyday denial as cultural, something that children learn from adults. We learned what to ignore and what was irrelevant, taboos, tact, avoiding the obvious. Denial is socially constructed. The silent bystander implicitly accepts the speaker's denial, and silence breakers are sanctioned by being discredited or ridiculed. This happens on Twitter all the time. And it also, this last point may help explain why we fail to talk about the climate crisis. Because we know that there's a backdrop of some ridicule and a lot of or I shouldn't say skepticism, because skepticism is actually healthy, cynicism about climate science. There's a lady named Sally Weintraub. In 2019, she wrote about how neoliberal culture actively dissociates us from our caring side. And she said it works to uncare us. Denial, and particularly disavowal, is a concept that can help us better understand our difficulties in facing and responding to the climate emergency, but not when applied in a blanket way. In general, the concept can help us see we have a range of ways to ward off reality, either by keeping it at bay for the moment or by having more rigid ways to block awareness. So many people may unconsciously be in a state of disavowal about the climate crisis because it's too painful to process and because they don't know what they should do. By providing an awareness of our interconnection with nature, this can help with that, because people might feel overwhelmed and then they could possibly slip straight from denial to despair. If they also believe that climate psychologists, that we have a human capacity to be more aware on like an intuitive level of the interconnection with other than human beings, such as plants, and animals, and that this capacity is internalized through encounters with others who, when we are troubled, provide the right balance of support, compassion, recognition, and challenge to help us. Such encounters provide a containing psychological space in which experiences such as grief, hurt, and rage arising from personal or political events can be digested. And I would propose that the Climate and Ecology Workshop, with all of us being here, we're containing our fears and resisting just running away and not facing reality. And yeah, thank you for listening. And if anybody has any ideas or anything they'd like to comment on, I'll just conclude with an idea I had, is that we need to look at the non-material side or aspect of a just transition, because fighting climate change isn't just about science or solar panels. It's about our relationship to nature, and this involves how we perceive and relate to the natural world. If we see it only as a resource to extract and use, we may not be able to overcome the worst of climate change. But if we can re-envision our interdependence within it, we may be able to lessen the planetary crises in the long term. Facing reality is the first step towards change. It's important to talk about what's happening to our planet as a consequence of our human activities for the past 70 years. We need to show compassion for others' fears, and that involves educating them and helping them to change their mindset. Thank you for listening. Oh, Deidre, do you have a question?
I just had an observation because it really, we are on a platform where disinformation about climate change is being amplified. And it really struck me with Hurricane Helene in West North Carolina. And it just devastated those communities. And I saw these very uninformed narratives start up, you know, like, oh, there were planes flying into the hurricanes, and that they were retweeting like posts by the hurricane hunters saying, you know, look, we're flying into the hurricane to, you know, measure it and you know, help get more accurate information about where it might make landfall. And another thing was there was radar, I think it's called backscatter, but there were like little glowing, if you looked at radar images, there were little glowing patches, and people were explaining that, you know, that's a natural phenomenon. Another thing was I was in a room with people who were saying, well, you know, I just starting to kind of explore, you know, like conspiracy theorists saying, oh, I'm not really a conspiracy theorist, but what if there really is weather modification? And one of the things that was helpful was to just explain, like, look, this storm is 100 miles tall, and it releases the same energy as a 10 megaton nuclear bomb every 20 minutes. There is no human technology on Earth that can steer such a beast, and no windmills don't have any impact on it. And it really was a question of science illiteracy combining with, it turned out the Russians, the later report came out, Russian bots on the platform were really pushing the amplifying the conspiracy narratives. And so, you know, I just started trying, I figured out the hashtags they were using and started trying to repost explanatory posts with those same hashtags. So, for example, HARP, you know, also explaining what HARP did, but I really saw it starting there, and it was like people have been, like, a lot of distrust has been sown of mainstream scientists. So what the scientists and the journalists themselves post isn't as credible on this platform. So it really helps to have members of the community. And I did do that with a space that I convened to, and a FEMA person ended up, she's really high up in FEMA, ended up attending. Somebody, and there was a lot of false narratives about the FEMA response as well. But it was like, it's easiest right when the false narratives are starting, as studies show. And I just think it's critically important that people be able to learn from weather disasters like Helene. And I think, like, what happens on this platform is important. You know, I think it's also important to get out things on more friendly platforms like Blue Sky and so on. But there's still a lot of Americans on this platform, unfortunately.
I related to that, Deidre. I had someone respond to one of my posts, or maybe it was the Climate and Ecology Workshop, I'm not sure, but basically saying, what are you doing on here? If you think that way, you should be at Blue Sky. That to me is code red for everyone who's willing to put up with this stuff should stay on Twitter to make sure that we have a discourse about climate and about right and wrong and about what we should be doing. I mean, I think Sal's service to us all is invaluable because people aren't being taught about climate science. And, you know, I was even thinking the other day, I wonder if people actually know how to read a graph. They understand, you know, about the x-axis and the y-axis, and they might not. I mean, I'm willing to bet 50% of people don't know how to read a graph. So that's something we might want to look at. Yeah, I mean, with oh, go ahead.
No, a long time ago, I actually started to teach. This goes back about 5 years ago. How to do graphing, because some of my graphs get really complicated, and there are ways to uh, present data that are easier to, to show people what's going on. And as I've discussed many times in the past, how I used to do these beautiful charts that were meant to be projected to an 8-foot screen where people across the room could see them because they were on an 8-foot screen. And now everything is on a 6-inch TV, sorry, a smartphone. So people have to know how to present data on essentially a postage stamp.
I did
Right.
want to say, just real briefly, that one of the helpful things I try and do is, and when I'm in, I mostly don't try to engage with hardcore deniers, but when I'm in a thread, I had dealt with a lot of Leon Simon's followers who had other problems. They believed they had no agency. But I first would acknowledge their emotions, and I'd always try and be respectful. But I'd say, well, there's this fact. And I'd recognize that in any given interchange with them, I wasn't going to move them that much. But we would have dialogues, and I'd say, well, there's this fact, and there's this fact, and there's this fact. And I just would be careful, and I kind of tune my response to what they were bringing up. And I found actually Grok is super helpful, giving you a fast summary of the facts. So I started using Grok to help me. But I do that. I've also done it with anti-vaxxers. And then somewhere in there, and I found that people are just, if you're insulting or whatever, people just turn off and they'll argue at you. So I have to kind of consciously not return anger for anger and say, well, I understand you're upset about this. And so I did that with the hurricane people about FEMA. I said, let's say, it's not acceptable for anybody to die because FEMA's not there, and we're really everybody here in this room is concerned about it. Saturday will be there's something playing that's making it difficult for me to. Oh, that's better. Thanks. So anyway, that kind of attuning was really important, and I've actually done psychological studies that are tuning about common values is helpful. We all want our communities to, thrive or things like that. Who has
That's getting harder
in the background? I'm not understanding. Okay. Yeah. But that's been my experience. I kind of want to write it up a little bit more because it's a little different than Michael Mann's calling it out. There's the TV again.
Well, that's actually I've got voices in the background, so sorry. I'm gonna. I can see about picking the cat off of my lap. He's not the one who's speaking. And moving to a different location. I assure you, the cat was not speaking.
I think also I was thinking about this. I have and experience with science, with academics, with trusting academia. Maybe it's because I went to university, and I'm wondering, if some of the distrust that people might have against academia and against the experts is because they don't have the experience and the association with it and don't see firsthand what goes into scientific research. But yeah, I think that's something we have to try to fight against, and to be, to make scientific research much more accessible to people.
I see Oliver has a hand up.
If I could just, or go ahead, Oliver, and then.
No, it's all right. You go ahead, Deirdre. Go on, because you were in a flow there.
I was going to say, just my entire life, I've dealt with anti-scientist narratives about me, like I'm not emotionally literate because I'm a scientist, or scientists are an ivory tower, or there's just a whole lot of them. And I dealt with them about Michael Mann, that like Michael Mann wasn't emotionally literate, or he didn't understand how to communicate with people. He's actually one of the best science communicators on the planet.
He is.
Yeah.
He is. I agree with you completely.
So it's really important. We all have these stereotypes of scientists as nerds, and there definitely are nerd types in science, but there's a whole range of personalities in science, and it helps to recognize that, and it also helps to kind of, a lot of what I did when I was defending Michael Mann was humanizing him and pointing out what he'd gone through with years of hate and death threats. And it's like, yeah, he's got a really strong personality, and he doesn't brook people contradicting him on his posts, but there's a reason he developed those kind of defenses. There's a reason he's quick to block. And it helped. That was, I think, one of the greatest services I did, was I sort of advocated for him with people, as there was a lot of anger against him. And
thank you for that. Thank you very much,
I saw
Deidre.
him as, scientist as punching bag too. I've seen famous scientists be like everybody's emotional punching bag for what people are unhappy about. Peter Hotez has some of that too. So it's just saying that the
Oliver,
rest of us can do a lot.
Hi, Oliver.
Until Oliver joins.
I am here. It's all right. It's just my funny little phone. It's not very good at the button pushes on the mic and that sort of thing. I don't know why. It's just a funny little phone. I should get. It's a sort of child's toy, really, isn't it?
Oliver, it's been like 3 years.
You know what I just bought? You know what I finally bought that might help you? I haven't put it on yet, but do you know those things that it's like a suction thing that you put on the back of the phone, and then you could hold the phone with that?
I've got one.
I forget the name of it. But it might help. I'm just saying, because it just makes it so you don't have to like wrap your hand around it.
Oh yes.
And I think it might free it up.
Oh, lovely.
I'll report back and let you know.
Sounds great.
How it
sounds
is.
Like a sort of a baby's dummy almost, that you can keep it wedged on and secure. Yeah, sounds excellent.
Exactly. Exactly.
But what I was going to add to the science topic is that it's very clear there are some brilliant scientists at communicating. I can think of a number of them. Obviously, Mann and our Swedish chap here in London. I've forgotten his name for some reason for a moment, but he's really good as well. Very tight. Stephen's very keen on him as well. But the problem I see with the science is really that it's complicated and people cannot get it, and they will never get it. Really, they'll never understand it. I'm afraid. I mean, I hope they do, but they won't. The amount of they'll just switch off. The eyes will come down. They'll just, they won't get it. However, there is a gap between what is known, if you like, and understood in the science community, and what is actually can be conveyed to the general public. There is a gap there, and there's an awful lot that could be achieved there that will, if you've pardoned me saying, make it more interesting to people and more compelling as well, so that people will start to really understand it. Because otherwise, if they don't get something, and it's going to take an awful lot of what exactly you've been talking about, climate psychology, get the psychologists talking to the people with their skill set, rather than the psychologists doing all the other work in the world at large for oil companies, for supermarkets, for producers of one thing or another, but all the time giving out the modern, if you like, information that they have them coming back into the climate and somehow giving their skills to the climate community. Because I don't know what the money's like, but obviously the money is much better elsewhere. They're getting more pay elsewhere. So
boys and ever.
Yeah. I mean, it's obvious they're going to be, the money is going to be attracting them away from climate. There's some way of getting them into climate on the money, right on the money. That's going to help too. But the main thing is there's got to be a gap that needs to be bridged by your good climate psychologists above all, and they're obviously underway on that. It's going to happen. It's a given thing. Somehow, when that gap is achieved, then people will start to embrace it much more readily. They'll get it. They'll understand. It will even become interesting for them. They will be drawn away from the day-to-day business as usual models that they're fed and fed and fed, and it will make a difference. I'm quite sure of it. I really hope it does, because it's a massive subject. It really is. I take a lot of interest in it, as you know as well. I think it's a terribly important subject. That once you get the people on your side, then the battle is won. And whether you do it through demos or marches or whatever, it doesn't really matter. But the easiest way is to get people, on side through their wallets, through their daily lifestyles, through their understanding of what's going on in the wider world, in the wider climate. So yeah, good luck.
Well, it seems like, Oliver, that we now have it that the majority of the people believe in climate change. They believe that it's human caused. They believe that they could get harmed from it. But now we need to, I guess, support them, help them, aid them with like the next step of, I want to be engaged, I want to make a difference, instead of, because I think some of the people who experience the disavowal become doomers, become, they just say, it's not going to happen. No one's going to change. That's just the way humanity is. It's too overwhelming. It's too big a problem.
And that's if they get that far, if they get to doom. I think most don't even get to doom. They get to, going out in the garden and mowing the lawn, or going to the supermarket, or taking the kids out for a day out. It's very sad. Anything distracts them, they'll take it. You were saying.
Right. And that's it. We live in like an entertainment culture. We can distract ourselves and escape from reality just by picking up our phone.
Yeah. Yes.
Let's finish this segment off with Deirdre, and then I'm gonna in the old rip up the script for my part two, and I want to get as much audience participation on part two as possible.
I did want to say, so I worked in California Water for, it's now going on 15 years and doing messaging. And one of the things we would try to do is find those teachable moments. And so, bad droughts, floods were teachable moments. And that's when really needed to be all hands on board, and we'd have some very clear common messages that we'd be getting out, and we did manage to get things out, and we had both in mainstream media and on social media. And I've been trying to, find a way to organize people more to do that kind of messaging during climate disasters. Michael Mann was doing a lot of really good work. Like he was narrating and during like the wildfires and heat waves and stuff in 2023 and 2024. And the problem was there was a division between him and the climate left, and people who would have been engaging with him and amplifying things were just not doing it. So I keep trying to do that, and I regularly engage and amplify. Michael Mann has left the platform, but Dr. Genevieve Gunther
I
is
think I
still
actually
there.
saw a
She's
tweet of
really
him yesterday.
What?
I think I did see a tweet of his yesterday.
So he's having his media team do periodic posts. His engagement is down because he's not getting replies. But he said he wasn't going to reply to accounts. I have some suspicion that it might be him posting and not just his media team. But you can use it's called Fatica. You can use an app that'll just post things. So, but yeah, he's the main place he is on now is Blue Sky. But yeah, there's Genevieve Gunther is still on, and Daniel Swain. I think Chris Kalos is still on. Where we have lost, the vast majority of climate scientists, and I may start cross posting some of those things, some of their stuff. But it is a problem because we need some larger accounts. It's by replying and boosting the larger accounts that you get reach. And I hope we can do that. I'm certainly trying to help boost things on other platforms like Threads. I'm also on Threads and Blue Sky. So, but it's like we have to. Working as a team is really important on social media too, in terms of taking advantage of those teachable moments. But there's like kind of overall strategy and tactics, and I think just getting to a point where people understand and agree on a strategy is really important. And I really appreciate Kim for I think climate psychology has a lot to teach us, and I started looking into it too, like around 2021. So thank you, Kim, and thank you, Saul.
Thank you. Okay, what I was going to originally do, and I kind of got into paleoclimate earlier, so I was going to break this down into 3 parts: modern climate, paleoclimate, and climate or science epistemology, which I was describing as how do we know what we know. So I think because I already did 3, I'm going to jump 2. I'm going to jump straight into 3. How do we know what we know? And this is one of the most important things to realize when it comes not just to climate, but to almost everything we do. Nothing we measure, other than using our eyes, and even that is extremely complicated. Nothing we measure is a direct measurement. Everything is a proxy measurement. So what I'm going to ask the audience is, what have you measured in the past using any instrument? And I'm going to tell you what you really measured.
Okay, I've got one. I think it might stump you, though. It's not really fair. How about a cup of sugar?
Oh, that's different. That's an eyeball. You are essentially you're using a predetermined volumetric amount which essentially, generally, it's just a mold pressed a piece of metal or a piece of ceramic into a form, and then, which of course can change over time. And now you're using your eyes to estimate what one cup is. Maybe you're going to use a butter knife to scrape over the excess, or if it's coffee, like I'm going to do, is I will tamp that thing down to get as much into that quarter cup as possible. Even though it's no longer a quarter cup, I'm displacing all of the air inside of that quarter cup by pressing down the ground beans. But that's really just an eyeball. But I'll give a few examples. The first early thermometers were essentially looking at how water or alcohol, or later on mercury, would rise in a cylinder, or you know what, all know what the basic thermometer looks like. But you're not measuring temperature. What you're measuring is the volume of that liquid as it runs through a graduated, typically it's a simple cylinder, up the working end of the thermometer. So you're not directly measuring temperature. You're directing the way temperature affects a liquid, and we're identifying that based on a model that we know how volume is changing based on temperature. So it's a proxy measurement. It's not a direct measurement. And sometimes trying to get deniers to understand this is worse than pulling teeth. It's like pulling tooth on a tiger as it's trying to eat you. But this is one of the most important topics in science, and I think in climate science, because so many people say, well, you're only using proxies and they are not accurate. And I'm willing to say that on some proxies, they're as accurate as anything we measure. When we look at paleoclimate, what we're looking at most commonly is the ratio of an oxygen 16 molecule, which is an atom, which is the most common of the oxygens, to oxygen 18, which has 2 extra neutrons, 16 versus 18. When that plankton or that dinosaur or that shell was formed, the temperature of the oceans, if it was warmer, then that would allow more heavier oxygen molecules. I keep on saying molecule. Water molecules that have oxygen 18 in it to escape the surface tension. So the higher the content of the heavier water molecule, the higher the temperature that occurred when that fossil lived, or when they ice sample was buried under the Antarctic ice cap. So what we're using an isotopic ratio to tell us what the temperature was. It's not direct, it's indirect, but it can be as accurate as a thermometer. A lot of people in the past have said that we changed the way we used to measure temperature. We only measure it once or twice a day. But that's not true, because we use something called a James 6 thermometer. It's fascinating that this was invented in 1776. So sorry, 1766. And it's essentially a U-shaped thermometer with tiny, tiny pieces of either metal or bone, shaved as thin as possible, jammed onto the top and bottom edges of the cylinder. And as the water or alcohol or mercury warms up, it pushes that little plug up or down, depending on if it's the cold end or the hot end, and that records the maximum and minimum temperature. If temperature rises any further, it's going to push that little plug a little further. If temperature cools, it's going to push the other side, the negative side, a little further. So you have a way of recording temperature that was invented in 1766. So we've been using the same methodology of maximum temperature versus minimum temperature and then dividing that by 2. I mean, it can't get simpler than that. The response speed of a liquid in glass thermometer, mercury thermometer, is a few seconds. So if a change occurs, instantaneously, you're going to record what that temperature was. You can record that minimum temperature or that maximum temperature. It's amazing how this has been the same methodology that we've used, although we're no longer using liquid in glass anymore. We're using, let's say, for argument's sake, we have thermistors, which are little diode devices, 4 cents a piece. You can understand why we use them. You pass a current through this. You can create something called a current mirror, where you can create a known current going through it all with always 1 milliamp or 10 milliamps. And now you measure the voltage across this diode. And as that goes up and down, the voltage, you know what the temperature is. So you have a way of very easily measuring temperature by measuring a completely different parameter. Does anybody want to ask how we measure something? Because I can keep doing this for hours, but it's more fun if you ask.
Well, I'm looking at limestone and the way it's formed over millions of years, and the way that marine creatures lay down their bodies and drop and form layers of sediment that eventually, from those bodies precisely, end up in the seas, in the presumably quite warm seas at the time, into limestone, which is anywhere from 160 to say 190 million years old. And even how that measurement can be deduced. You alluded to it, Sal, just now. This is just
temperature is isotopic. You measure oxygen versus oxygen. But the age of materials, we have 5 different, I don't remember them all. We have 5 different pairs of very, very long-lived isotopes. I think there's like a lead and I forgot the other one. But for argument's sake, you measure the difference between potassium and I forgot. Again, I forget. I'm sorry. You measure the amount of a radioactive material and the element 2 down from it, and the stable material. And we know roughly 700 million years ago what that ratio was. So if you look at a fossil and it has a certain ratio, you now can say, okay, 216 million years ago, give or take a 500,000 years, that was the ratio of those 2 isotopes. For Earth, we use 5 different ratios for cross calibration. That's why we know the Earth is roughly 4. I love the fact that it's 4.545 billion years, but it's plus or minus 0.01. So there's the plus or minus is actually larger than the resolution of, but roughly. So yes, we do it indirectly by measuring isotopic ratios, which are incredibly accurate. Because when you're using a gas chromatograph and you're burning off a microscopic amount of material, you're actually liberating trillions of atoms.
Yeah.
And you can count the scintillation counters, like you have 18,643 of one, you have 16,219 of those. So you plug in simple ratiometrics, it's a logarithmic scale, and it's aged to within a tiny fraction of how of what it is. Side note: religious fanatics love to say that the Noachian flood caused a change in the strong force, which changed the rate of radioactive decay which is why the universe really is only 6,000 years old, but it spoofs that because the decay rate changed after the flood. So it's one of those wonderful little. That's not exactly the gotcha you think it is, because that's not going to pass any scientific muster. But the people who don't understand, they might get fooled by it.
Yeah, and the thing is, you know, when you work with these materials, you become involved in the process of millions of years, because you can taste and smell the ancient crustaceans themselves as you carve them. You can actually, it has a very particular smell. It's somewhere between slightly fishy or slightly, it smells like heavy engine oil, a little bit like that. So it's a sort of funny mixture of the two. But what you do find is that you are you are at one with the material. And of course, there's another thing: is we find iron in particularly in sandstone. We find lumps of iron, but we also find it in limestone as well, and we call it dinosaur dumps. So you know, it's always worth. Sometimes go on.
It's not what I would ever do. But yes, there's a lot of paleontologists, a lot of geologists will actually taste the sample, because the way it feels on their tongue will give them ideas as to the granularity of it, how well it retains water, how bitter it is, and if they still survive doing that, they can learn about the material by using their tongue as a tester, as an instrument.
Yeah, sommelier.
That's beyond me. But I can see the value of that, because you know it's our tongues do have an incredible capacity to measure not so much viscosity, but the resistance to you moving over an object. You lick something, and is my tongue moving quickly, or is my tongue moving slowly? And those little papilla on your tongue can feel the shape, and can give you clues to, like, yeah, that's really very smooth. That's not smooth at all. That's extremely rough. So yeah, it's a measuring tool. It's a perfectly valid instrument.
I hope the archaeologists didn't do that with the woman they found in a peat bog just recently. She was, you know, they didn't say directly that she was a human sacrifice, but it's pretty likely she was, and she wasn't like anything like the really fancy ones in Norway, Finland. I'm not sure, Sweden possibly, the bog people out there. But she's pretty good. You know, they found a pretty much not completely intact, but more or less intact. Woman as well, which is different, certainly. I hope they didn't do any the lick test. You'd hope not. I don't think they did.
I know recently there was discussions about Otzi, the guy who they discovered in the Austrian border.
Oh yes,
and
yeah.
It appears that he had Lyme disease.
Yeah, funny, isn't it?
So
yeah.
they found the Lyme disease bacteria in his tissue. So yeah, it's I mean, I hate to ask this terrible question, but is it possible that Lyme was I'm not going to say extinct, because it wasn't extinct, but could it have been a geologically reactivated disease based on how as permafrost melts, or the Alps melts, it then releases paleo bacteria.
Quite possibly. There was a slight risk when I was doing a tomb in West Norwood Cemetery for a bridge engineer, actually, a rather good one called Cubit, not the builder, but another Cubit. And there was concern that there was horsehair with anthrax from China that was in the coffin. Or in the, you know, in the
Oh
actually,
God,
yeah,
that lasts forever.
yeah. Well, I
That's
think.
that's into the, yeah, that's into the centuries.
Well, I'm still here. Maybe I'm carrying it.
Thank goodness.
But again, measurable. You see, yeah. I was going to say, I gave you a block and I'd carved a face out of it in profile, and you weren't sure what was the size of the block when it started, could you be able to work it out from the figure itself, from the face that was sticking out of the block?
Oh, it's, you don't know how much has been removed. It's I imagine that that there are one of the things I'd mentioned earlier was how we know how much ice extent, general ice extent, and sea level based on particle size. You go to any beach and you see the size of the sand slash rocks slash pebbles,
Yes.
and that tells you how much activity, how high the tides are, and how quickly the tides are moving in and out. If it's very very fast, soft tides, then you're going to just have grains of sand. But if you've got boulders nearby, that tells you that you've had spectacular amounts of height change over time. And like not too far away from Kim, you have Bay of Fundy,
Yeah.
where
Wow.
40 something, 43, 44. That's what 12-meter
Yep.
tides, which is just mind-boggling how you can that can possibly happen. But yeah, so you can tell based on the universe leaves clues that as we get more intelligent and we understand more about the universe, we can decipher and we can interrogate.
Shell drifts are very interesting on beaches too. I find some beaches don't have a lot. Some beaches in Scotland have an amazing array of shells, and they usually like to be deposited in their own sort of regimented manner. It's rather strange, but it's very it's a lovely thing to find lots of shells on beaches. I find, but especially like
But
carrot. Mm, right,
but
what?
there's a secondary thing about that. They could be that could be oyster beds or sea beds, but it can also be shell middens, essentially people's garbage cans.
Yes.
And that's something that's also that's very very useful for identifying literally signs of life.
Yeah.
You dig down and 7 meters deep and you find a shell midden and you say, okay, people were here eating off the beach 16,000 years ago.
Mm. Yeah, you do find a lot of that on the Scottish island on Colonsay. They do that. There's quite a lot of that goes on. Yeah, and quite far
Are they
inland.
deep fried?
I think so. Yeah, and they they basically mussels. I think they had some clams, and they had all the weird stuff. Like the sort of tubular shells as well. Whatever they're called, worms, aren't they? That live in the shell. So yeah, there was all sorts of stuff in there. But that was
Razor
quite.
clams.
Yeah, that's it. But they were quite inland as well. That's the thing. So I guess they were just hauling them off the beach and off the sea, and then taking them in off for food, away out of the wind, as it were, or whatever, and the rain. Yeah, as you do, of course, and more measurements though. Yeah.
Giza.
Mm.
Yeah, I had sort of a more fundamental observation, which I shared in the pill, that it's that the ways in which our society constructs reality has fundamentally changed with the shift to social media. I took this reply to Peter Hotez, but reality is actually, Eric Fromm had this theory that reality is partly an intersubjective construct. That is, it's a subjective experience shared by more than one person. And so we think of, it's the physics you've been explaining, and the physics that people believe in is what tethers, science to objective reality in climate science. And as it gets, climate science gets very complex, and the construction of reality and the fact that the planet's warming from, physics gets more complex. But as you're right, and as you keep explaining, there's very fundamental physics underneath it. But the whole process of meaning making in our society um, has changed in that people are like exposed to narratives on social media regularly, and they're exposed to things that are counterfactual. For example, there was a narrative that there's a lot of wildfires in California, and it should be um, just very clear evidence that it's been getting warmer, the forests are drying out. But there's always I saw some videos of people sharing, and they're like, "Oh, we just saw a van full of immigrants, and they set a fire, and then they drove off in another fire." And it was this guy sharing it real time, and it literally creates a counterfactual narrative, and people in these social networks are exposed to it over and over again. And so the reality in a context in which it's accepted as reality, so they're literally living in an alternative reality, and it really is a challenge. And um, people, there are a lot of people that may be so far down the rabbit hole, but it's important to understand, and you see that with the anti-vaxxers too, that um, that like they get story after story of vax injuries, and they get a steady stream of it on their feed, and they see the incidence is way higher than it actually is. Go ahead.
Oh, yeah. Anecdote is very, very powerful, and people will believe what occurred to people in their lives more than other people. Uh, so one event happening to someone near you has the equivalent of 1,000 non-events, things that never happened to anyone. It is problematic. It's the personalization of information has more validity than the bulk of information, which is exactly the vaccine issue. There were in the United States a few hundred cases of myocarditis caused by the vaccine, the mRNA vaccines, and there's not a single known validated U.S. death from mRNA, and there's not a single validated case of um, clotting in any adult. It's just a few teenage boys. Uh, that is different from the Johnson and Johnson vaccine, but of the mRNA vaccines, they are as close to being without uh, incident as any we've ever seen. I Part of the reason I chose today's topic was I spent about 3 hours arguing with a guy about climate, describing exactly how we know what we know. That this isn't just guesswork, and this isn't just somebody came up with this because they were paid to. The brutal fact is, I earned a nice living as a research and development scientist, and if I my wife, who I helped her and I helped her boss. Her boss was a world-class neuro-oncologist, as knowledgeable on the topic as possible. PhD, fought for every penny and every grant she could get. She was earning less than me. And it was just breathtaking and heartbreaking to see how, in most research and development topics, in most, for medicines, for physics, for earth science, especially for field biology. I've dealt with so many people in the field biology world where essentially, for all argument's sake, these guys are earning minimum wage or even lower because they spend so much time in the field that they're not being paid for. Like all the park rangers that Trump is firing, because apparently having park rangers is bad for our for our economy. That having skilled people in the woods to make sure that other people don't get eaten by bears is somehow bad for the country. But yeah, this is the problem is we have the wrong priorities.
Just as an aside, recently I've been made re-aware of Mary Anning, who's the Mary she sells by the seashore, and her life story. Actually, my son's taking an anthropology course, and they brought up her as a subject matter, which I think is quite fascinating. And I think she's the turn of the 19th century, around 1799 or something like that. And I think it might be a great story to promote, because here we have lower class, working class girl who fell in love with shells and fossils by the beach, and had to convince the scientific community that there was something valuable in studying this. So it could, I think it could, like, she could sort of be a bridge story for people maybe who don't trust science, and that the experience, the life experience that she brought to the study of it, aided science.
If I could say, I think efforts to reduce hate against scientists is just as important, because there's an emotional component of this. It's called affective polarization, but they've been, promoting distrust and even anger and hate against scientists. And you can really see it in the Pew Research poll that showed a huge decrease in trust of scientists to act in the public interest. And it really it started to go down during the COVID pandemic, and those narratives were very harmful, not just, I guess, not just about, COVID researchers and vaccinologists like Peter Hotez, but just general science in general. So anything, and the problem is when I show data to an anti-vaxxer, and there's very clear data that 200,000 more people, or 300 more people died who were unvaccinated in the U.S., and they're just like, oh, the data is false. The data is falsified. And so, like, getting them to, it's something the scientists themselves can't do once the anger and distrust has become too extreme. They literally can't advocate for themselves. And so having just regular people sharing it and saying, and I always try and be respectful of other people, because their distrust is very real, but it's just a process. There's so much terrible things happening with defunding, the entire research enterprise in the U.S., that anything people can do to reduce outgroup hate of scientists and anti-science narratives is really important. It's just horrible. They actually had the delegation, the U.S. had somebody going to the IPCC meeting about, what climate reports they're going to do, and nobody from the U.S. is coming now. They stopped that person going. That's how bad it is.
Well, again, part of the reason for today's topic was because I deal a great deal with climate deniers, and they teach me what's wrong with them. To be blunt, by looking at studying their thought patterns and their the repetition of how they always use the same talking points, it immediately shows you where they learned it, what they, I shouldn't even say learned, where they established this misinformation, what they believe in. And as you ask them questions, as you interrogate them, they show you how, I don't want to say ignorant they are, but it goes beyond that, and how gullible they are, how willing they are to believe in nonsense, their inability to distinguish between facts and opinions, and their absolute stubbornness and refusal to uh, appreciate that, as I said earlier, why we know what we know. Uh, it, a guy this morning said, "Well, I looked at your website, and all you ever talk about is CO2." And I said, "I beg your pardon. My website is devoted to paleoclimate, and that includes solar data. It includes magnetic data. It includes a spectacular discussion on the Milankovic information. I talk about insolation, the amount of sunlight. So I actually do very little. I mean, look at my username. It's 25 cycle. That's I named this account after the 25th solar cycle. That's not CO2. That is the sun. And if you challenge people to tell you where they get their ideas, they almost immediately, the first thing they do is they will jump to a different topic totally. Why do you say that the sun is causing climate change? Because CO2 is plant food. This happened to me this morning. I'm like, beg your pardon. So how is CO2 is plant food mean that the sun is automatically causing climate change? And by the way, the next step when somebody says CO2 is plant food is you tell them, no, it's not. Uh, Plants are autotrophs. They make their own food. That's the whole idea behind photosynthesis. They take water and they take CO. They take 6 molecules of water, molecules of CO2, add sunlight, and you get sucrose.
Actually, I need that. Thank you for that, Sal, because I have been to getting that response to a few of my tweets, which is like greening is CO2 is greening and stuff like that. I just wanted to add to the point earlier. Deidre was talking about HARP and how it's teaching us about, was it about the fires?
HARP was about, they were thinking that some research project managing measuring the aurora in the Arctic was a weather modification project.
Oh, right. That's right. How that has become politicized is a really good example of how something, when it's a neutral scientific device or piece of science evidence, that it can get twisted. Because I know, with my son being on YouTube, he's on the young male algorithm, and part of that is pushing these Joe Regan videos. And we clicked on it just to see what it was like, and it was about HARP and how the lefties are using it to control the weather, and obviously that's what they're doing. And then they had guests on that was like validating what he was saying, even though it was a complete lie.
Darren, I wanted to say,
unsettling.
if I could say real briefly, the thing about CO2 is plant food. Michael Mann issued a short rebuttal, but if you could come up with something simple that rebuts it, it would be helpful, because the Secretary of Energy is now regurgitating those climate denial talking points. It's I'll try and find Michael Mann was rebutting it. I posted something rebutting it on Blue Sky, but I'm like, oh God. But it's something we need repetition. We don't have the kind of YouTube audience that Joe Rogan has, and it's a huge problem particularly with young men. young men were actually literally targeted for right code of conduct content in, the audience of American gamers was targeted in the U.S. election, and there's a huge um, increase in support for the Republican Party among, I think, under 29s and 18 to 29, and Genevieve Gunther thinks you can see it basically started during the pandemic, and suddenly people were online and shut down, and so online content started being much more determinative of opinions.
Just to add to that point, Naomi Klein says in Doppelganger that that's exactly it. During the pandemic, we were all on social media way more than we've ever been. And the right wing took advantage of that and took over a lot of left wing talking points and, sort of did a 180 on them. And then all of a sudden they became right wing issues rather than left wing issues.
This is hard to reconcile, because historically youth were more liberal, but I think a lot of it has to do with the fact that they don't have as much um, social interaction in a real world basis, a physical basis, as they used to. I mean, everybody who was alive when I was a child, or give or take 10 to 15 years. We played in the streets all day long. We almost never saw our parents. We didn't have helicopter parents. We were engaging with our fellows constantly. So school was out. You went out and you played for 3 hours, and you came back home. You did your homework, and you had homework. And, and
That's a key part there.
and so there was a lot more physical interaction with your peers, and you learned about how to cooperate with people. You learned about sharing. You learned about power sharing. You learned how to cope with failure. I hate to say it, but the everybody wins aspect of some modern sports is problematic in that you're going to lose once in a while, and be prepared. Don't let it get you down. Don't let it destroy your life. Yeah, you lost. Get over it. You'll win tomorrow, or you'll win the next day. So losing helps prepare you. I hate to say it, for maturity. Maybe the real problem that we have in modern society is this uh, astonishing belief that opinion is more than anything else what matters to shaping your personal reality. I always like to say that reality is what happens whether you believe in it or not, and it's what everybody else sees whether you see it or not. That's, I think, very, very Neil deGrasse Tysonian. But I'm sure he wasn't the first one to come up with it, and probably came up, probably was more like a Carl Sagan concept. But this is something that I don't think people are properly identifying in their own lives, which is why you have so many Republican politicians. I hate to say it, that, it does seem to be party driven, who believe in absolute insanity. I mean, Jewish space lasers. HARP is one of them. HARP essentially was a gift to Republican uh, Senator Frank Stevens of Alaska. It was a great way to get a project started uh, in his state, where they could pump hundreds of millions of dollars. So they would have the infrastructure, that they built roads, that they hired people, that they brought raw materials in. It was essentially a pork barrel. I mean, it was useful. It was scientifically very, very valid information. to learn about the Earth's magnetic sphere. But it was, for all practical purposes, pork barrel, Republican pork barrel. So now apparently it's the left wing that's running it, and it's the left wing that's destroying the world by creating all of these weather disturbances for a project that was pushed by a Republican senator. The reality is not what it seems, and sometimes you cannot teach people about this. And if you try to tell them how things actually work, they shut you down, and they just walk away.
Also, Sal, I think a difference between us and the I don't even know what they're called. I guess the millennials and the are they Gen Zers? Is we didn't have a cell phone. We didn't have a connection real time to the world. They all get different people that they end up following and liking, just like we do here on Twitter, on YouTube. And this person or group of people or matrix of accounts, I think probably has too big an influence on what they're thinking. And the thing is, it could be someone who lives in like the basement in Iowa that never leaves their house. But because they post funny videos and somehow they get, boosted by the algorithm, they end up having a huge influence on people. And talking about the gamers and the algorithm that goes there, well, I know my son, he watches some YouTube videos about Nintendo, and I think that gets crossed over to like I said, YouTube videos about Joe Rogan, and then some flat earthers that Neil deGrasse Tyson was coming out and saying things again. I think it might be Terrence somebody.
Terrence
I'm not
Howard.
sure, but
Terrence Howard.
yes.
I mean, yeah, we could do a whole thing about him, but yeah. He's trying to
It's
reinvent
really a different world.
trying to reinvent mathematics. He thinks that mathematics is wrong.
Yes.
So the sort of societal framework for how these kids are learning about reality has fundamentally shifted. And Joe Rogan was the top viewed podcast on the planet. I think Midas Touch did just recently achieve more views, but it's an issue. It's fundamentally changed it, and that's what I saw with Leon Simons challenging Michael Mann. I mean, Leon Simons has no secondary education in science whatsoever. He just had a business incubator, climate business incubator certificate from EIT Guelph, and yet he's challenging Michael Mann, and because he's bright and he figured things out, and he has 70,000 followers, people were treating him as equally valid to Michael Mann. And there were just a lot of problems with his posts. But it was really hard for me, even with some members of our own community. I interacted with a lot of them that, just like the social media influencers, seem to automatically have credibility from having large numbers of followers.
I like to joke that I was probably the first. I like to joke that I was probably the first climate scientist who was blocked by Leon.
A badge of honor.
I just found out the other day I'm blocked by him. I'm like, I'm blocked by him, but that was funny to find out. But I do notice, I think his name, he's a weather forecaster, I think from Florida. Is it Matthew Baradelli?
Oh,
he'll often post things. And I love his stuff, but I've seen him post things with like an @Leon Simmons. So he seems to be influenced by him at least a little bit as well. And a few other climate scientist people are CCing or @Leon Simons as well. Simmons. Is it Simmons or Simons?
Simons, I think.
Well, I know he's not in it from an English primary speaking language, so it probably is going to have a slightly different accentuation. And if anybody ever deals with him, you can tell him that I called him a complete and total prick.
Well, he is doing things that are very harmful in attacking climate models, leading climate scientists, and even IPCC. And I spent all time over last summer dealing with that distrust, and there was effective polarization against Michael Mann. People were absolutely convinced that Michael Mann was evil, and it was, Leon had this narrative that Michael Mann was deliberately lying and cherry picking his data, and they were the same kinds of attacks as from the far right, and it was incredibly harmful and divisive. And people were just utterly convinced that Michael Mann said, I seem to be an agent provocateur, and he needed other people to stand up for him. And I got dogpiled for doing it, but I finally normalized it within the community that, yes, people do stand up for Michael Mann and support him. So.
Scientists, I'm sorry, let me do this quickly. People who really worked in the sciences, people who really, studied hard in school and sacrificed to learn all of this stuff are inherently conservative when it comes to new information. We want to be, it's a great idea. Now repeat it. Show me a second paper that says the same thing. I'm not going to believe the first thing, that someone tells me if it contradicts anything that's an existing validated framework. I need to see repeatability. So, yes, there's a lot of people who don't like that idea. They want to believe in the newest and latest and greatest, and they literally want to throw out the baby with the bathwater every single time something new comes out. So maybe this is a problem with people like Leon, that because they've never learned the science, they don't have the intellectual rigor of a scientist.
Exactly. You put it in one, that is. If you watch him on YouTube with Dan, what's his name, who runs the climate blog, Dan Miller. If you watch him with Dan Miller, he's a very insecure talker. Is Leon, and he actually is encouraged by Dan, and they get stuck into all the geoengineering and so on. They really do get stuck in. Yeah, you get really stuck into it as well. And now they are quite convincing together. They're quite a good double act. They get involved, and they've got quite a lot of people watching. And it does, unfortunately, it does bend minds a bit too. We all know that shipping, emissions do have an effect on cloud and on various aspects of that. But it doesn't necessarily follow that you have to have shipping emissions just because they do have a good effect. It's still a nasty fossil fuel after all, the very worst fossil fuel. But no, they are quite keen on the stuff. They'd rather put it back.
I have gone on record asking people if they could please, just one person, show me a paper that identifies the forcing function of SO2. It's a negative forcing function. Give me one paper that accurately says within plus or minus 10% what the forcing function of SO2 is. And there is none. So how on earth can you say, well, this is definitely the cause, when you can't even identify, you can't numerate it, but you can't put any quantities on it? I mean, this is essentially John Shuchuk or Matt Weilicki territory.
I did want to say it is one of the largest uncertainties in climate science, and there was some very important work being done by CLIVAR, which is a project of the World Meteorological Climate Variability and something or other research. And so there was some IPC lead authors on the platform, like Christy Price-Desescu, who was a lead author, and Pierce Forster, and they were saying, that Hansen's paper was a bad paper. Piers Forster said, it took pot shots at climate science at the IPCC, and it was really unnecessary, and he did a disservice to all the people at the IPCC who scientists donate years of their lives to doing the synthesis research, and so what happened was Hansen came out with this broad, sweeping claim that, I've single-handedly solved the grand challenge of climate science, which is, narrowing equilibrium climate sensitivity. And by the way, it's at the high end of the range that people previously thought it was unlikely. And, I've solved it. That's it. And all Michael Mann said was, extraordinary claims require extraordinary evidence, and I don't think that bar has been met. And further,
Oliver had asked me if we were going to talk about that paper. Oliver had asked if we were going to talk about that paper, and I said I meant it 2 weeks ago, but the fact of the matter is I was not kind.
Yeah. Christy Price-Duseku said it was a bad paper, but he didn't want to speak publicly about it, and I kept having arguments. So the completely counterfactual thing that Leon Simons did, that was kind of basically religion, and Hansen was, it's a real world experiment, reducing shipping emissions. And so since we reduced shipping emissions and, there was a step increase in warming, therefore all the climate models are wrong. And it's like, you're not controlling for other factors. So this guy TC had an argument with him, and it was like Dan Miller just trolled him really badly, and TC didn't want to engage anymore. And I retweeted what TC said over and over again because Leon Simons was being really misogynistic towards me, and I'm like, you don't know anything. And I've done work at 2 national labs on computational modeling, physical modeling. I did work at NASA Ames Research Center and Los Alamos National Lab. So yes, I actually do know something about it. I have a whole, I have years of experience in training in climate science and programming. So I know a lot about models. I know a lot about their limitations. And part of the reason Leon was rejecting models, and when I get to it, is Daniel Swain and some other scientists predicted that, yes, there was impact of IMO shipping emissions, but it was regional and would be short term. And the modeling came out and they showed it was regional, mainly in the North Atlantic, and it would have a short-term impact. It wasn't this, in that the impulse will wear off after a couple of years. So it could explain part of what happened, but it wasn't this, oh my God, it's triggered runaway warming. We need to go back and sprinkle sulfate all over the atmosphere.
I wasn't going to go that far into it, but I can go a little farther into it. I want to just very, very quickly say that when I did my discussion on our discussion or my input to that discussion on Hansen 2025, the first thing I said was right at the start of the paper, he's talking about the jump step in temperatures between 2023 and 2022, which is so disingenuous. Because 2016 was the hottest year, and then you had a couple of 3 consecutive La Nina winters, which is almost unprecedented. And then you had 2 consecutive El Nino winters. So this is not normal, and this is, you can't all blame this on SO2 when you have all these other factors that you are completely ignoring. And of course, adds the fact that although it's only a small factor of it, 2023, 2024 were solar maxima. So that adds another 0.05 degrees to the mix. So when you look at, 2016 and 2020, which were the 2 previous hottest years, even though Hansen says it was a 0.4 degree jump between 2022 and 2023, it was only a 0.15 degree jump from 2016 to 2020. So he more than doubled the jump because he ignored so many other years. And that is such bad science. Oh, and by the way, so nobody's jumping in. The problem that I have with SO2 is there's several different aspects of it. The first is sulfur dioxide is a very heavy molecule. Because it is a heavy molecule, it is not going to displace across the entire atmosphere as well as CO2 or H2O or any of the biatomic molecules, N2O2. So it's got local stiction. The second is uh, upwelling IR, which we discussed earlier. It's not quite uniform throughout the entire planet, but it's close enough. SO2 is a mirror and it blocks sunlight, which means that it is extremely localized. So if you have a lot of SO2 on the equator in the summer, it's going to have a much greater effect than if you have a lot of SO2 in the northern hemisphere, the high latitudes in the winter, or conversely, in the southern hemisphere's winter in the high latitudes. So it is very, very important when you talk about SO2, where it happened, when it happened. You cannot just do a blanket statement. And that's why all of these papers are completely and royally sparked.
I did want to explain. So Glenn Peters actually had a really interesting. So I do nonlinear dynamics, and when you take the nonlinear trend, a lowest locally weighted scatter plot trend, you find that looking at the difference, that it was more that 2021 and 2022 were unusually cool. And
Yes.
there was cooling because of the Australian bushfires in 2020. They had put a whole lot of black carbon in the atmosphere, and there was a publication that indicated that was partly why you had the triple La Nina. So that I shared this. Glenn Peters is at I think Cicero, and he's a really good climate scientist. But the other thing is there is proposed to be some acceleration in warming just by the climate models. And so if you don't do it relative to the linear trend, but do it to the nonlinear trend, you see this very clearly. So that was part of it. I would say that there is still something we don't understand, and that the half a degree C jump in temperature in September of 2023 was a very rare event in the climate model. So that is something they're looking to explain, and there does seem to have been a step increase in global temperatures at that point. Like normally you would expect it to go down. So there is an area of emerging science, but it does not look like it's shipping emissions. So anyway, that this is the kind of thing that Leon just doesn't understand, and you were right, Saul. It was a very simple sort of, let's fit one line here and look at the trend, and then more recent years, let's fit another line. And Michael Mann gave a very eloquent explanation of why, where the line broke was really arbitrary, and you could get all kinds of different effects. So using locally weighted scatter plot, Lois, is much more is much better. And I've been thinking for a while that, like looking at linear trends in a nonlinear system is going to lead to problems, and that seems to be one of the foundational reasons for so many arguments and lack of understanding about it.
My ears are tuned to the two lead scientists in Berkeley Earth, Rhodey and Housefather. They are stellar. They are as good as it gets. I they are my number one and my number two in the currently active science community. And then you have a ton. We did this in a space about 40 weeks ago. We have a ton of paleoclimatologists that have come out in the last few years, and they are doing absolutely spectacular work. And none of these people are, they're not doomers. They're not the end of the world is nigh. They do repeatable work. One of my absolute favorites is the Arizona State team, Osman and Tierney. They just did a spectacular paper I mean, Jessica Tierney is like on every third paper now in paleoclimate. She is all over the place. I used one of my favorite graphics is the Yamamoto paper that she was second on, which I absolutely love. Let me go into deeper display. There is a new way to measure CO2 levels. Obviously, trapped ice was one way, but what Yamamoto, Tierney, in fact, Tierney, she's left us. She's only on whatchamacallit, Blue Sky. Actually, I don't even know if she's on Blue Sky, but she's no longer on. Her Twitter handle was @leafwax, and the account no longer exists, which really hurt because she's like, because I love her work because she is willing to share her raw data on GitHub more than almost any other scientist. So she puts it out there for people like me who are dying to find raw data. And that really, helps the community because it's out there for people to see and to work on, and it's open. But Yamamoto, 2000 and I forgot 2017, whatever. They're using leaf wax. That is the outside of leaves that were deposited from the Ganges River over millions of years, and slowly, as you get flooding during the summer, the leaves get washed downstream. They get buried in the Indian Ocean, and then the next year is buried in the next year, and so on and so on and so on. And you can drill a kilometer deep bore, and you can pick out leaf wax from not completely destroyed leaves that go back 1.5 million years, or I should say 1.5 million years, not 1.5 million. So we had this amazing CO2 archive that is longer than the ice archives, that's more regular than the ice archives. We have other very, very good CO2 sources. But the other advantage of the Indian Ocean is it's almost on the equator. And most of the time when we get proxies, they are Antarctic or Greenland, or even a few of the proxies are Himalayan. And this is warm weather, and it's easy to get. You don't have to. I mean, yes, it's a lot of work to drill a core in the middle of the Indian Ocean, but you don't have to send an expedition into Antarctica for 7 years and drill a 3-kilometer ice core and gently pick it up piece by piece and pray that as you're removing it, you're not contaminating it with previous years of ice as it melts its way down. The leaf wax is just much more pristine. Yes, Deirdre.
I did want to say this. So there is an IGCC, without getting into too many details about one individual study. So Piers Forster is the lead author on IPCC Chapter 8. He's been the lead author for a while. And he recognized the need to have annual updates between IPCC reports. I think IPCC reports are released, about what, every 4 years? Is it 4 or 5? So he has these, it's called IGCC, and he's got 50 co-authors, and every year he releases a report on, looks at Earth's energy balance, looks at temperature trends, and that's really the best high-level synthesis of all these different papers and sort of what's happening with the climate. Not sure So they have the 2024 one out. I was citing the 2023 report a lot. Sort of the big takeaway in 2023 report was the most recent temperature warming trends were unprecedented at the time of AR6 and have increased further since then, showing that human activities are consistently causing global warming recently of more than 0.2 C per decade. So I refer to this graph a lot. It's probably one of the clearest representations, and it shows the kind of the warming hiatus that we were in and how we emerged from it around 2013. So that's probably one of the best kind of overall takeaways, and that report is super helpful because there's a lot of different paleo reconstructions, and if you look deeply into the paleo literature, the problem is the paleo constructions don't necessarily agree with one another. So
Yes.
there's still a lot of work being done by scientists to synthesize them. And Piers Forster was also on a paper with Christy Pristescu and Kyle Armour, who were both IPCC lead authors, and they did have a paper saying that the previous constraints on the high end of equilibrium climate sensitivity might not be correct. So they're probably the leading researchers on this, and I try and follow their work. Christy is a theorist, and even I find some of his papers to be, very deep. But the other ones are good, and you can read the abstracts. So
by the way,
I'll try to. I got this with Elliot, and I'll put it in the purple pill.
in the last 5 minutes, the last 90 seconds, I just decided for the hell of it, even though they released the data about, I don't know, 3 weeks ago, NASA just released new series data today, and I'm looking through it briefly, and it's going to be another one of those, we're going back into normalization. It looks like EEI, Earth Energy Imbalance, is dropping. It's going to take me a few hours to do all this work. I'm definitely not going to do it during this. Maybe I'll do a series rundown. That's CERES, not SERIES, rundown next week on the data that I'm looking at right now. But it looks to me, I mean, this one blows me away. Cloud visible optical depth, which is a fancy way of saying how dark the clouds are. Clouds are getting darker. Now, what that means is there's less sunlight coming through, but there's more IR being blocked by the clouds. So it's the old question, like there's, oh God, Spencemark, who claims that, oh, well, the global warming is caused by cosmic rays creating more clouds, or reducing the amount of clouds, and therefore it's causing differences. And this data is going the exact opposite. This is why I have no hair anymore. For all practical purposes, the data we're getting is so contradictory in so many ways. Is it clouds? It doesn't look like it. Is it the sun? It's definitely not the sun. It's everything is pointing more and more clearly at upwelling IR being blocked by the atmosphere. Did I accidentally hit on?
So is it actually the concentration of CO2 parts per million and other greenhouse gases?
Yeah, it's definitely because every natural cause that I've looked at, I've spent, I don't know, 7 or 8 years carefully studying every one of the natural causes. I did a long-term research on. Yeah, I'm retired. I got time on my hands on the Milankovic cycle and the Milankovic cycles until like the last 20,000 years gave me nothing. Could not, make heads or tails out of them. And then the last 20,000 years, suddenly it's like, oh yeah, this is definitely what's causing everything. The dramatic jump in northern hemisphere insolation, that sunlight that came into the northern hemisphere roughly 22,000 years ago. Because if you ever look at any paleoclimate graph, you see that the Earth was pretty damn cold until about 12,000 years ago, and about 22,000 years ago, we were at like the bottom of how much sunlight the northern hemisphere got, and then suddenly that shot up for about 13,000 years. And about 7,000, 8,000 years ago, it started to go back down again. And that's roughly all of the papers, all of the paleoclimate papers in the Holocene era, which is like the last 20 something thousand years. Holocene goes further back, but all modern Holocene papers are now so closely tied to sunlight in the northern hemisphere that I'm completely convinced that natural climate change explains everything perfectly until 1850. And then all hell breaks loose. Oliver.
Oh, this is just to come back on Tierney. Is it Jessica Tierney that you had in
Yes.
mind? She's she's at leafwax.bsky.social. If anybody wants to,
I thought she would be.
yeah,
I thought she would be. Yeah.
And she's done some really interesting stuff. You should check her out, people. She's really like a wizard on deserts, which is a big future in deserts. And she sounds really nice.
What?
And
Arizona State.
What? I also have a playlist, of Milankovic cycle. I have a Spotify playlist. It's very, very peaceful, very restful one. If you like to look it up, yeah, it's about 15 tracks, but they're mostly new age stuff. It's not rubbish. It's nice stuff. You might enjoy it. It's quite restful. I put that together a while back.
Yeah, she is, as I said, she's a paleoclimate hero.
Yeah.
And you have I forgot Caitlin with Witkowski, who did the long paleoclimate, the 455 million years of paleoclimate.
Oh,
which
right.
is
480.
Yeah.
That's a different. That's
a different one. I'm sorry. Okay, I'm getting confused then.
That's Judd. I forgot who's the second on that. Then that's Wing, Huber, and Tierney. So Tierney's on that as well.
She only has 1,000 followers on B-Sky, but it's new, I guess. And she's only following.
I was looking for her.
She's only following 113, so she's quite picky. Or she needs to get on some of those lists.
I did just share the paper I looked at Kyle Armour. He hasn't posted recently, but he did lead this paper on constraining equilibrium climate sensitivity and the use of pattern effect. It's really a major paper in paleoclimatology because it's used to constrain equilibrium climate sensitivity, which is the $64,000 question. So I highly recommend reading
that.
Thank you, Deidre.
Sorry, quickly, what's the ESS range? Sorry, ECS or ESS?
It's ECS, and I
what's
don't
the
remember
ESS?
the exact. Yeah, ECS.
Because Hansen is now saying 5.4, and that is just way out there. That's essentially double the quote unquote consensus. And I do this examination every few months. I piece together what the last 75 years of data shows us, because after all, the last 75 years, although it does include other forcings, is when we've done the most on essentially a daily basis of climate reanalysis. And it's funny because Hansen, 1981, is right on the ball, and that's 2.8. And now he's saying 5.4? It just makes no sense to me.
So Kyle Armour, they said, combining the last glacial maximum with other lines of evidence, best estimate becomes 2.9 C, 66% probability range, 2.4 C to 3.5 C. And
that's Hansen, 1981.
Yeah, and then so this is Kyle Armour, and then 2.1 to 4.1 C is 5 to 95%, substantially narrowing uncertainty compared to recent assessments. And they used the pattern effect to consider climate to look at the last glacial maximum. And ironically, that's what Hansen is using to say is the last glacial maximum underestimated equilibrium climate sensitivity, but Kyle Armour's research is much more careful and really thorough and really not biased towards I'm the lone climate prophet and know everything and I'm warning people about the impending doom. So there still are other things that we don't, that may be a problem, like sudden permafrost thawing, but that particular paper is helpful.
I do want to.
This is why. Let me finish this. Let me get this in quickly. This is why, again, I have such a problem with Hansen, because the Milankovic cycles perfectly tells us what happened in the last 22,000 years. So anybody who's giving me CO2 and is not looking at the sun is just screwing up royally. Climate is holistic. It's not one single thing happening. Sorry for the rant.
Okay, you've made that clear now. You know what? I mean, I remember reading in Hansen's article, which I don't have my glasses on, so I can't see the title of, but that he said a range of ESS from like 4.4 to 5.4 or something like that. So it was, he did give a range. Another thing I remember about his article, this is as a layperson, of course, is that he talked about how the reason why he's increased the range is because of observational data, which the IPC models, CC models, aren't really taking into account. So that would be one of the things that he says. And then another thing, and just in general, is I do encourage people to read it, even if you don't agree with the conclusions of it, is because it's a great climate science education paper, but it also proposes solutions. And he brings in ideas from Greek mythology and kind of like, and philosophy. So I think it is, it's a very interesting paper to read. And I think the United Nations really supports this paper. They did host a discussion on this paper on Zoom. And he does have other like co-authors on it as well. So I think the way I look at it is that if he is right about shipping emissions, isn't that even more reason that we should be cutting our CO2 emissions? Because guess what? We can't pollute the world and kill a bunch of people to keep the planet cool. That's like, that form of geoengineering isn't going to work. So we really have to work on decarbonizing our economy. That's the way I look at that. But I know, there's infighting within the scientific community about estimates and what the numbers really mean. But as like a person outside of it, what it means to me is it's another one of these, it's a wake-up call. We've got to do something, because there are some scientists that are saying that the warming is occurring sooner rather than later. And I just wanted to invite Kiptu to speak if he would like to, our friend from Kenya. So I see that he would like to speak, but he's very polite, so he hasn't put up his hand. So in case he would like to, please, Kiptu, feel free to join in.
Yeah, thank you very much, Kim, and I've been following the conversation. I really appreciate what you people are doing, and our friend really bad at names has been like over there each and every Friday hosting spaces in relation to addressing climate change. And yeah, that's what we need as a community. That's what we need to overcome these challenges that we are facing. Like I've been talking to Kim, telling her that I'm from a community where we still lag behind when it comes to knowledge in relation to climate. And most people from my community believe that these are natural things that are beyond our control, and the root causes of catastrophic climate event is when we offend our supernatural being. And that has led our leaders to behave abnormally when it comes to things in relation to addressing this climate change, because they know that the community doesn't have that much knowledge in it, and so they will joyride. Anytime we have like projects that you need to follow up and ensure that they follow those protocol in relation to protecting the nature and ensuring that they are friendly into our environment, they tend to allocate money for that kind of project, but for those factors, but they are not going to implement them. So if they are building roads, they will find that they will cut even those natural big trees that have been there for long, and they won't do anything to plant them, or even take care of those sites that they were using maybe to excavate those building materials. And as we are working forward, I can say I am among the few people from my community who are now coming up and even talking about climate change, because I can remember very well in 2019 we lost over 20 people in a very bad landslide in just few kilometers from where I'm living. And even I can say my friends and even close friends of mine, family members, even my clan members, some of them died during that event. And I'm now using the event to paint the picture of the impact of climate change to our people, and telling them, if we were to prevent, if our society could have been like working towards addressing these things, like not cutting trees on hills, and also doing agriculture on those stiffy places, we could have saved these lost lives. And also calling now the global north, who are now the main polluters, and the USA to also start paying for their pollution. And now they are getting to understand that we need to be like, even if we won't do much to ensure that we address climate change, but there are some other things that we can do and minimize losses when it comes to lives and also property, and at the same time minimize the impact of the climate change. So I can say we are moving on to the right direction. I'm very bad when it comes to science, despite doing agricultural economics. So I'm learning, and each and every day I join these spaces, I just want to know more in relation to how science and climate change. But I can say I've taken part in a number of events and also a number of activities. I've taken part in demonstration. I've taken part in even national locally, national, and international platform, and I've been advocating for climate action and climate justice. But it will be much better for me, and it will give me more strength when I gain this knowledge that I gain each and every day we have this space. So I don't have much to say today, but I really appreciate this kind of energy that I usually see each and every day when it comes to matters addressing climate change. Thank you, Kim, for the invitation, and enjoy, everyone.
Let me warn you, the dangerous part about learning is it makes you want to learn more.
If I could say something, I just wanted to read because I feel like people mischaracterize the conflict between James Hansen and the IPCC lead authors. And Piers Forster, who led the chapter 8, said his commentary is terrible. This is simply a very bad hodgepodge of a paper made out to be a new assessment of climate sensitivity and critique of the IPCC. It is nothing of the sort. Instead, Foster said the paper is a combination of historical perspectives, geographical modeling, and Hansen's opinions. The high climate sensitivity estimates cited in Hansen's paper all seem quite subjective and not justified by observations, model studies, or literature. They portray their paper as an alternative, but it doesn't have rigor, systematic analysis, or comprehensive literature review. It also does a great disservice to the hundreds of scientists from around the world that gave many years of their lives to the IPCC process. Hansen's non-scientist co-author Leon Simons was angered by Forster's smearing and defamatory comments, and he's continued to attack the IPCC and said the IPCC process is keeping people ignorant, not informing people about reality could cause very serious harm. That's the definition of gross negligence. And it's easy to both sides, this kind of dialogue, but it really is a fundamental attack on the synthesis, weighing and synthesis of research papers by the IPCC and that's sort of the foundation of climate science. One trajectory of the Earth system, so we use climate models, and there's paleo reconstructions, and there's just a lot of differing interpretations, and people really do put a lot of effort into trying to comprehensively and objectively weigh the evidence. But I agree with Piers Forster's paper. That was definitely the opinion of other leading climate scientists. And so I would urge people to read the IPCC section on equilibrium climate sensitivity as a real grounding. Hansen, that paper has been promoted extensively in the online community, but it's as a major paper. And in fact, Trenberth made the point that there was a lot of extraneous material and that Hansen had shopped it around, and that he thought a lot of it wouldn't have even been publishable if he'd had a stronger editor. So it's hard for me to see this both-sided, particularly when I've spent so much effort and time trying to straighten it out, and Dr. Mann himself has been under so many attacks. Dr. Mann is much more careful and rigorous, and although it turned out him saying, this is just El Nino, La Nina, looks somewhat wrong, it was not the great, in that there was a step increase in temperatures. It was not the great runaway warming, equilibrium, increase in Earth's energy imbalance. As you said, it's going down. So anyway, that's all.
Just very, very quickly. Actually, two things very, very quickly. One is I just posted to the Jumbotron a graph I did about, 3 or 4 weeks ago. This is an update. This is the CO2 and E CO2. That uses essentially taking all of the, and this is not the Montreal gases or the industrial gases. And if I add those, it's going to really go crazy, but I only have like 40 years of those gases. If we look at CO2 and CO2 equivalent, which means what happens if we take the forcing of CH4 and N2O and we convert those forcings into how much CO2, and we get a CO2 change since 1750 of roughly 148 parts per million. But if we add CH4 and N2O, we get roughly a 225 equivalent change in parts per million of CO2. So what that does is because we had other gases that increased so dramatically at the same time, this reduces the net effect of ECS, because now you have to take into account that those gases as well were added. It's very, very hard to do ECS based on only one gas if the other gases are not standing still. And I'm going to redo an ECS. I plan on doing it. I don't know when. Soon, of course. I'm going to do an ECS chart of the last 270 years, an estimation based on CO2, and that's probably going to be about 2.3 or 2.4, or maybe even lower. So there is a lot more to talk about here.
I just wanted to verify, Deidre, are you talking about global warming has accelerated? Are the United Nations and the public well informed, which was published in the Environment, Science and Policy for Sustainable Development article?
No, this is the global warming in the pipeline paper.
Okay, sorry, I was referring to a different paper. I apologize for that if there was a mix-up on my part. But I was, because I didn't find this, I didn't get my glasses. The article that I was referring to is in a peer-reviewed journal. It is called "Global Warming Has Accelerated. Are the United Nations and the Public Well Informed?" And in this article, I think it's a great teaching article. He explains climate forcings, aerosol and cloud particle microphysics, the evidence of aerosol climate forcing, sea surface temperature, global temperature response to doubled CO2, different climate forcing scenarios. And, he does call it the point of no return. He looks at ice sheet, ocean, atmosphere interactions, ice melt, sea level rise, and he has a section called "The Next 2 Decades," and he gives solutions of what we could do, and a lot of that involves young people.
So
because it's their future.
I did want to read, and so people are aware of the criticisms of Hansen. Kevin Trenberth, who was incredibly involved in looking at decadal scale climate variability and the causes of the hiatus in global warming. He's a lead, preeminent researcher. And he said he was surprised that global warming in the pipeline was published, noting that the journal is relatively obscure. He said, "I think it's likely wrong. Hansen has never been involved in the IPCC in any capacity, even as a reviewer. He is not at all collegial, and he tends to ignore legitimate criticism. He moves papers around until they get published. He stuffed papers full of extraneous stuff that would not be publishable by itself." He said the new paper relies on an estimate of paleoclimate sensitivity that was proven wrong by a 2021 study. That Hansen's teams also seems to have ignored increasing water vapor caused by global warming as a factor in the recent warming surge. He said water vapor is a major feedback. As temperatures go up, so does the water holding capacity of the atmosphere. And I did discover that climate models have errors in representing water vapor in the upper troposphere, the lowest layer, upper part of the lowest layer of the atmosphere. So just be aware, and it's important to read more than one paper, but that's why I kind of, just because a paper is peer reviewed doesn't mean the most credible papers are published in Nature, Proceedings of the National Academy of Sciences, and so forth. So it, like Hansen is a maverick at this point. So just be aware that it's a maverick paper, and some of his conclusions in there may not be consistent with mainstream climate science, and we're not in global warming in the pipeline.
And
the issue that's not a problem, but the issue was that he, and particularly his co-author Leon Simons, was using that to attack leading climate scientists and the IPCC and climate models, and we're still dealing with the fallout of sowing that kind of distrust.
And there's one other note, and I mentioned this also 2 weeks ago. There is absolutely no research, no new research done by Hansen 2025. It is a meta study of other papers, and not a single piece of data in that is from him. And that really should, I don't want to say disqualifying, but it really hurts the paper dramatically, because he's just rehashing other people's work and creating different interpretations that are completely against the original author's works. If you did that to him, he would go apeshit.
Synthesis, that's often why. So I learned about this. I worked with Michael Dettinger, and he kind of schooled me when I was starting to do my own synthesis of climate science, and he explained, how things are discussed and debated. There was a huge amount of intense discussion and debate during the global warming hiatus, but it was mostly collegial. There weren't these kinds of attacks on climate scientists, and I've got to think that it gained traction because of the social media environment we're in. There was uptake of narratives about Michael Mann that he was cherry picking data and deliberately lying, that were literally from the climate deniers, and that had never happened before.
It is astonishing to me that we have man is being attacked from both sides. He's too much of a hockey stick guy. He's not enough of a hockey stick guy. I normally do this earlier, but we have reached the 4-hour limit. We're going to close it up soon. I hear Kim begging for mercy on the DMs. So let's hold it for a few more minutes. Does anyone have anything to say? Any topics they want to bring up? In the near future, we're going to do a little. We're trying to have some, because this was a heavy today, and I still didn't get to all of paleoclimate. But we're going to look to do fun topics. We wanted to discuss perhaps climate in science fiction, or geology and slash other. I mean, Dune is of course the most the easiest target to hit. But we want to discuss fiction and art, and especially after a pure physics day like today, to do things that are fun. So does anyone have anything to add? Any questions? Please, if you ever have questions, please bring them to us. Bring them to me. You can at any time you have any question on anything, you can either DM me, or you can just put a comment on any of my on my, oh my God, so many tweets, or Kim. Bring it to our attention, and we'll be happy to discuss it. Because it's fun. The more audience participation we get, the more ideas that you guys come up with to make this exciting, spirited, entertaining. We're more than happy to oblige, and because it's also fun for us. So, anyone else? I guess that's it then. We've cracked the 4 hour mark. I've almost cracked my phone screen. My earbuds battery is screaming for mercy. Thank you all for coming. Uh, it was a pleasure. It was fun. Thank you, Kim, for co-hosting. Uh, Deirdre, you came through like a star today. I know several people here couldn't speak because they had people coming in to work on their houses. So we'll get you next time. So probably going to be back to Thursday next week. I'm getting, oh, where is everything? Uh, so we're gonna, probably back to a Thursday schedule next week. Probably back to 10:30. We'll see what happens in the near future. Spring always brings surprises. So once again, thank you for coming. It's been a pleasure, and we'll see you next time. Bye bye.